Good morning, everyone, and welcome to the DNS Working Group. So you can see the agenda already on the screen. First, we have a small announcement for everyone who wants to vote at the general meeting today. Please note that you have to register to get your sticker to be able to vote. And also, it is already mandatory to have a two-factor on your account. So if you haven't set that up, please do so in time, just so you're not getting into a little bit of a time hassle later today. Yes, so the first small point on our agenda is the new chair selection. It was Moritz's end of his first term, and he got re-elected, so that's apparently a good sign for him. I hope you're already happy about that. I am. Moritz, are you here already?
Yes, I am. Yeah, thank you. I also take this as a good sign. I'm sorry that I couldn't be here with you in Krakow. My wife is expecting a baby, so I prefer to stay at home. But I'm looking forward to the next Friday meeting.
Yes. Best of all reasons, exactly. Yeah, congratulations.
Thanks.
Okay, well then, let's get on with our first speaker. That is Peter Thomassen with DNSSEC, bootstrapping support in not DNS and in PowerDNS.
Yes, hello, this is Peter. I assume you can hear me. I don't have a share button, which is fine. I do actually, okay. So 1 second. Here we go. Can you see this? I suppose you can see this, otherwise you will complain, probably.
Unfortunately, no. Oh, no, that's the wrong slide. Wait a second.
Elmer says it looks right to him, so.
Oh, now it's fine. Okay.
Okay, cool. Okay, so I will give an update on the implementation of the DNSSEC bootstrapping protocol. And before I go into technicalities, I'll first explain what it is very quickly. Some of you probably have heard of it, so I'll keep it short. If you would like to enable DNSSEC for delegation, you have to put DS records into the parent zone. You know, DS records are a hash of the validation key from the child. And the way that usually works is that the registrant has to talk to the DNS operator, hey, give me the parameters, and then they forward it to the parent, either to the registrar or the registry. And that's, you know, people often don't know about it, and it is quite slow process. It's easy to make mistakes. There's different formats. The interfaces differ by registrar. It's quite a process if you are not a very technical person. So a much better thing would be if this was automated and without the human being involved. And so there is actually RFC 8078 for that. The DNS operator puts CDS record in the child zone, and the parent can discover it. And so the human doesn't have to do any copying of cryptographic strings and stuff like that. But unfortunately, there hasn't been authentication for that so far, because usually CDS records are signed by the DNSSEC key that you use for the child. That's fine for updates if you already have one. But if you provision it for the first time, then obviously you don't have a chain of trust. So this is the problem that we're trying to solve. So from Insecure, I just mentioned before. So if you have example.com, for example, and the DNS operator puts the CDS records, the parent can look at it and provision the DS record set. But this step here doesn't really have authentication, right? So what to do about it without having to trust things on first use? The idea of the protocol is that we know that the DNS operator has name servers, right? So they have a host name, for example, ns1.provider.net. And if we put a constraint that DNS operators supporting this protocol should sign their name server host name zones with DNSSEC, then you can use that name server host name to publish stuff on subdomains of it and make announcements about zones that you host, so like public authenticated signals. And the way that is used here is that the CDS and CDNS records that you publish in the child zone, you can publish also an identical copy of at a subdomain of the name server host name. So if the child zone is example.com, here the copy owner name would be _dsboot for DNSSEC bootstrapping .example.com ._signal, and then the name of the host, the name of the name server host. And so this can be signed with the DNSSEC key that the DNS operator has for their own domain. And parents looking at this can then also go and validate that copy using DNSSEC. So they can verify that the CDS record in the child zone is actually the one that the DNS operator endorses, and that way kind of transfer trust from the DNS operator to the child domain. So this uses an established chain of trust. It's kind of a detour, and it's authenticated. It is immediate. You don't have to go to different portals and log in and stuff like that. And it is resilient against on-wire attackers, and in that sense extends the existing RFC. So how about the status of the protocol and implementations? The protocol has passed IETF last call and is about to finish IESG review. There's one minor text issue to be resolved, and then it'll proceed to get published as an RFC. There are implementations on the parent side for this processing stuff at switch, for example, for .ch and .li. And some GTLDs are also working towards deployment, although there is some intricacies with ICANN regulations and all of that, so that probably will take a little bit. And on the child side, there are implementations at various operators like Cloudflare and Glauca Hex DNS. Those implementations, I think, are proprietary. And then at DESEC, we use the implementations I will be talking about now. So those are essentially the news and have been developed earlier this year. So, for example, if you use not DNS, there is now a module that's called auth signal for authenticated signals from the DNS operator. And it is able to produce the CDS and CDNS key co-published records under the name server host name. So typically, if you have the example.com domain, for example, in your not DNS configuration, you will have some configuration file like this. It has a zone, block, and then, domain example.com, and it has DNSSEC signing, and you might have some other domains. So this is what you already have, and the new thing is the blue code here. So you can add another domain, which is the _signal.ns1provider.net, if that's your name server host name. And you will have to turn on two modules. One is the online signing module, because responses are generated dynamically upon, at query time. And the online signing module needs a specific configuration. So that's up here. That is something that you don't need to touch. It just needs to be there. And then also the auth signal module needs to be enabled as well. And this takes care of responding properly to queries like the one we had earlier on the left-hand side of the diagram. So that's all you have to do for not DNS. And this is in the stable release currently. For PowerDNS, it is not yet merged. An implementation is available and expected, I think, for PowerDNS 5. And there are still decisions to be made how exactly to do it. Both of them are pretty simple, and I'll display them here. So first of all, you have to create the zone. That's like creating any other zone. And for simplicity, I used an environment variable here to capture the name server host name, because it will appear in other commands too. Now, the first approach of how this is implemented is that you have to secure the zone. Then you have to set specific NSEC3 configuration stuff, and specifically you have to put it in narrow mode. That's the last word in the second command, which is essentially what PowerDNS needs for its for the way it works with online signing. Then you have to call rectify zone, which is another internal thing. And then the actual new thing is set meta signaling zone 1. This will cause PowerDNS to synthesize these signaling records. And then you can see, of course, that those four commands kind of go together, because the last one doesn't make sense without the first three. So the second approach is essentially just encapsulating this in one command. So this will be decided later. And so this is how the PowerDNS implementation will work, either this or the other way. If you feel like experimenting, you can take the code from the pull request that's linked here. There is also one other implementation that I didn't mention earlier, which is for setups which can't do online synthesis, so which don't have any keys on the secondaries, for example, or that use name servers like I think NSD, which don't do online signing. In this case, it will be useful if one is able to generate a signaling zone with all these copied CDS records from a list of zones that you manage. And so we wrote software that can do this in a kind of general way. There is dsboot generate. It's on GitHub, and it'll be on PyPy, I think, later in June. And it accepts on standard inputs NS records, with an owner name and with a name server targets, and also CDS and CDNS key records. And from that, you can infer what the names would be of those signaling zones, _signal, blah, blah, blah. And you can put in the corresponding copies of CDS records, which you also take from standard input, which also have owner names, so you know which child domains they are for. And so from that, you can construct this stuff, which is what the program does. You can also override things like hard code the name server host names on the command line, or you can specify parameters to write the output, not to standard out, but to a file, or you can have it read in an existing signaling zone for updating it instead of creating a new one. And so here's an example of how you can use it. You call dsboot generate, and you put the read flag to read an existing zone file that is expected at the canonical name in the current directory, and the write flag to have it updated on disk. And we tell it here in the two command line arguments that we want the two signaling names to be signaling zones to be under the name servers ns1.desec.io and ns2.desec.org. And now from standard input, we take those CDS records for Thomassen.io, for example, and that will cause the generation of these records in the output, essentially. You can also update the signaling zone file to delete CDS records that you no longer need. Perhaps you don't have the customer anymore, or the zone already has bootstrapped or something, in which case you can put in the NS records only, in this case for the child domain deleted.test, without putting CDS or CDNS key records, and the software will remove the corresponding name node from the output file. Yeah, so this, I guess, can be plugged into signing pipelines or whatever people have if they don't want to use online synthesis. Now, the last slide. So upcoming developments are to improve the efficiency of the whole thing, not specifically of bootstrapping, but of CDS processing as a whole. It's usually implemented by parents as a daily scan, which has lots of traffic and things rarely change. So it's a lot of fishing and casting nets for very few fish. And also the timing is uncertain. For example, if the parent runs it every night at 3 a.m., if the CDS record is published a minute earlier, then it'll be effective immediately. And if it's published a minute after, then it'll take almost 24 hours for it to become effective. So a better way would be if the child operator could send a notification to the parent. And so for that, Johan Stenstam and John Levine and me have been working on the general notify draft, which has been adopted by the IETF. And it reuses the notify messages in DNS that are used for replication coordination. They have a field for a record type, and usually the notifiers are of type SOA, but you can, of course, put different types. So the idea is, let's have a notify of type DS or CDS or something and send that to the parent. The main question is, where exactly do you send it? Because you don't know who does the CDS processing. It could be the registry or the registrar. So the draft proposes to have a desync record, which is new, added to the parent zone or the subzone, which is called _signal. And so you essentially take the name that you're interested in for which you would like to send a signal, example.com, for example, and you insert the _signal label after the first label. And this is where you can expect the desync record to be. And it has, the record type it relates to, for example, CDS, and the scheme number, which is always 1 currently, the port number, which is here 51 as an example, and the host name to which to send the notify packet. And so this can be set up as a wildcard record, for example, if the registry wants to receive all the notifiers, or it can be done in a child-specific way if the registry somehow wants to announce the registrar's endpoint or whatever. So the protocol is agnostic about that. And yeah, so we plan to implement this in a few scenarios at the upcoming ITF hackathon in Vancouver, and then see if we can improve the DNSSEC automation landscape. That's all I got. The bootstrapping implementations have been funded by the NLNet Foundation, so I would like to thank them. And otherwise, there's my employer, and I'm happy to take any questions.
All right, do we have any questions in the room? Are there any online? No, not right now. Okay. Yeah, then thank you.
Thank you very much.
Let's move on with the agenda then. So next up is Dave Lawrence with DELEG update.
Good morning, everyone. It's so good to see you here. Sure, I get the right button. Hooray, it works. So many of you are already familiar with what has been going on to update the way that DNS delegations work. But for some of you who are new here, I wanted to give a really quick background. So back at the ITF in Prague last November, Petr Spacek wanted to have a brainstorming session. Essentially, we were looking at how to improve leg removal with delegging things. Oh, wait, wrong conference. What we really wanted to do for the purpose of the brainstorming was identify where the pain points were with the existing DNS protocol and how we might be able to advance on improving that situation. One of the things we quickly realized was that probably the best way to facilitate that was being able to signal between a resolver and the authoritative server when each was able to support a new feature of the protocol, different than the way that things are currently done. Right now, as many of you know, we have to rely on a lot of fallback behaviors if something is recognized or not during the process, and we wanted to make it more frictionless to identify while the resolution process was naturally happening. One of the other things we realized, besides enabling new features, this would help with some of the features that we've already approved. Notably, we have several different forms of encrypted DNS protocol that right now, in order to get to them, you have to have some kind of precompiled list or other discovery process that falls outside the normal DNS protocol. And so we thought that this could help with being able to use that more seamlessly. And so DELEG was born, short for delegations, of course, which was supposed to be an extensible parent-side record that could specify the attributes of the different name servers that a zone was being delegated to. So our initial effort actually was based on a draft that Tim April of Akamai had written back in right after the pandemic started. Not great timing for Tim. And he called it NS2 at the time. And essentially, it has much the same core ideas as what we pursued with DELEG. And then so Petr, Ralph, and I all signed as co-authors for Tim's draft to start moving it through the process because Tim is not as actively involved in the ITF right now. One of the other things that was really important was getting contributions from a large number of industry experts from across the industry. One of the frequent criticisms of the ITF standards process is that it is kind of ivory tower-ish, that it is not well represented by all aspects of the industry, but specifically by people, typically implementers who are really deeply involved with the DNS protocol, but not so much what running an operation is really like or what running a registry is really like. And so we had many people participating in that hackathon, but then some of the ones that also dug in with us in trying to get the DELEG effort off the ground included the names here, Roy and David and Manu and Shuman. There were many more contributions, some from others of you in this room. I can look and see right off the bat 4 or 5 people who I know also commented, and we very much appreciate all that feedback. So I'm sorry I didn't get to list everybody. I do want to call out Roy and Shuman for having done some important testing that proved the viability of the core concept, which was that if we added this new record in the parent, would it be true that old resolvers who have no idea what is going on with this would not be impacted by the presence of this new information? And that is largely a true statement, but we don't need to go into the details right now. So then we socialized it beyond that initial hackathon group. We were specifically looking, for people, anybody, ICANN, web implementers, anybody else who'd be like, oh my God, this is a horrible idea, please don't do that. By and large, the feedback we got was positive. That's not to say that people didn't have some concerns, but we received far more encouraging feedback about the possibilities than we did people telling us to hold off. And so that gave us the incentive to continue to pursue it. In fact, at the last RIPE, at the end of November, I socialized the idea here to the RIPE community. It was definitely aspirational. We came out hard saying, well, this is the way it's going to be. And it was hopefully even at that talk indicated as like, well, this is the way we'd like it to be, but we were definitely trying to give it a push in that direction. And again, the reception there was pretty positive. We've also talked to the operators at Nanog, and by and large, we still get more positive feedback about the idea of improving delegations than people saying, no, just leave everything the way it is. So we did publish the first draft in January, which is in the data tracker at the ITF. And the intent at the time was that perhaps the DNSOP working group could adopt this existing work, and then for any future protocol development that relied on DELEG, we could spin that off into another group. So for those of you who are not aware, the basic idea of the way that the record looks is that this is a parent-side record that does get DNSSEC signed, rather than relying on a transition into the subzone to get to continue the chain of trust. The mnemonic we've chosen is DELEG. And it looks a lot like a service binding record with key equals value pairs, where you can define different attributes of the name server you're talking to. Here's a really simplified example that shows what a typical existing use case of the NS record and glue records would look like. But then there were several other ideas advanced, including that being able to specify an ALPN, which defines the transport, for example, that you want to talk to a DO or DOT server. And similarly, we also realized that this could solve one of our big issues that operators have with maintaining DNSSEC at the parent in conjunction with work like Peter is doing. But in particular, we'd be able to specify, a service binding record in the child that identifies all the attributes of the name server, including perhaps DNSSEC properties. All the details of this are not that important for this talk, in part because things are in a state of flux, and based on what I'm about to say next, something might emerge that looks very different from the way we've initially proposed it. So the next step was after submitting the draft, was to facilitate further interest in the ITF, and a mailing list was set up, dd@ietf.org. I want to just point out real fast that those of you who know that my personal domain name is dd.org, it is completely unrelated, just a coincidence, not indicating specific advocacy for this one approach. That mailing was spun up to start diving deeper into it, and one of the first orders of business was to start a birds of a feather session at the ITF. This is essentially where a meeting of like-minded people can come together in advance to decide whether a problem is even worth working on, and if it is, how should that be pursued? A new working group, take it to a particular working group, and so on. So we did convene that BOF at the March ITF, which was recently held in Brisbane, and so the two big questions are, should we work on it? And if we did, should it be in a separate new working group? And so Wes Hardiker and Paul Hoffman very generously contributed their time in coordinating that BOF. The consensus from the participants in the groups was pretty much yes and yes to both questions. We should work on this, and that it should be in a new working group. Notably, that means that the new working group, which is not yet chartered, but soon will be, anticipated to be, is also called DELEG. And so now there are two things called DELEG. So when you're talking about it, you hopefully are going to be really clear in context which one you're talking about. And notably, whatever emerges from the DELEG working group might not look what the original DELEG proposal looked like. So then discussion on the DD list did continue in March and April after the BOF, focusing specifically on what the proposed charter for the new working group would be. And so the working group proposal is actually out and live now. The charter that is being proposed to the IESG, who must formally approve any new working groups, was just finalized a week ago. And it specifies a few different things, notably the expected documentation to come out of the working group is first supposed to be a requirements document that identifies really clearly what we're trying to do without listing the possible solutions for it. And then there will be, there's 3 broad areas of consensus about areas that could be addressed and that we should identify solutions and to put forward as drafts and eventually standards there. The new group is proposed for the internet area. For those of you familiar with the IETF, it's broken up into several sub areas which cover broad aspects of internet technology. The internet area is for the kind of the fundamental protocols that affect the internet as a whole. And that's where most of the DNS working groups are. Notably, it is not where DNSOP is because that's in the operations area. But the ADD group I co-chair, as well as DNSSD and DPrive, are all in the internet area. And Warren Kamari is proposed to be our new area director for the group. The other area director for INT is Eric Thank, who worked with Warren in getting this proposal off the ground. But ultimately, one of them has to take responsibility for handling the working group. The proposed chairs that Warren and Eric were finally able to whittle it down to are Brian Haberman, one of the DPrive co-chairs, and Dwayne Wessels from VeriSign, who many of you are very familiar with. And they had a lot of people apply for it. It made it really hard to identify, specifically the people they wanted to hone in on. But so there were balancing act going on there. I think they made a great choice. One of the new things that Warren wants to try is typically IETF chairmanships are pretty much until somebody taps out. And he wants to specifically have an explicit review of whether the working group chair should continue on essentially every 2 years after coming up. And so this will be an interesting new experience for the working group. The proposal is on the ISG telechat, which is their monthly meeting to get together to handle the current business of the ISG. And that should be a week from now. It is very likely that approval would happen, probably with a few more charter tweaks, because that is what the ISG does. So where that leaves us now is, in anticipation of having a new working group created, the DELEG draft offers, including Patrick, Ralph, myself, and Tim, are continuing to work on the original draft. We do expect to have an 01 version of the draft out in the data tracker before the Vancouver IETF. A little bit of shuffling. There was some feedback we received about areas that could be made more clear and so on. If you'd like to contribute, it is available on GitHub. Pull requests are gleefully reviewed. And at some point, we will be seeking adoption by the new working group, but probably not anytime before the Dublin IETF in November. In part because of this issue I mentioned, where the charter is pretty clear on saying we really should have a requirements document before we start having a solutions document. And speaking of which, the requirements document needs writing. I am about to send a message out to the DD list, said, hey, by the way, has anybody started on this? Because I'm unaware of it, but just because I'm unaware of something doesn't mean it hasn't happened. I'm interested in contributing to such a document. If you are, also look for a message on the DD list for how we could possibly get started on this if it hasn't already been. And I will also note that one of the things that has come up both in DNSOP and then in the DELEG BOF is that there are some competing ideas about how we could advance this core idea of improving delegations, including things like hacking the DS record. I'm not particularly in favor of those other approaches. We like the approach that we like, but it should be noted that they're out there. And one of the interesting things about this, I think that whatever we come out with, even if it is not our original DELEG proposal, and even if it's not a DNS hack, a DS hack, is that we've added friction to the system. And one of the great hallmarks of the internet has been that relatively frictionless ease with which things can be innovated, but the IETF adds some friction, but it generally adds friction to create a better end product. Like there are several things that have been implemented outside the IETF, then brought to the IETF and improved by the process, or unfortunately had to document well, here's what exists and here's why it has engineering faults, but you're gonna have to live with them. So I don't know whether any of these other ideas are going to come to fruition as drafts themselves, but we will be looking for the possibility of that, and it will probably come up again and again while we start honing in on just what the requirements are and then what solutions we can do. I will note that already somebody eagerly submitted a EPP draft for registry extension working group for facilitating the communication of DELEG from registrars to their registries. But at the moment, because we really don't know exactly where DELEG is going, Gavin is probably going to have to put that on the back burner until something more concrete starts emerging. And I am right at the end of time. And so if you have any questions, I'm happy to address them. I will note that, well, first I will blame Willem for the whole DELEG pun, because I think most of our Dutch colleagues tend to pronounce it DELEG. And don't do Google image search for DELEG things, because you get a lot of undesirable responses. Any questions? Hello, Mr. B.
Jim Reid, just a random member of the DNS group here. Nice presentation, Dave, and you summarised the situation fairly well. Two comments just for the benefit of everybody here is that it's not necessary to fully go through the ITF process and have a working group forming BOF before a working group is formed. And the vision of the opinion of the ITF leadership was that the BOF in Brisbane was so successful and constructive that essentially all the nits and bumps had been taken care of, and therefore go straight forward to go straight directly to forming the working group once we got one or two things sorted out with the charter. I think the other concern that we're going to have when the working group meets for the first time in Vancouver is there's going to figure out how we're going to timetable all the work, because there are a number of different, in some cases, overlapping or competing ideas. And I think it's going to be a big challenge for the working group chairs in particular, how they're going to try and coordinate and trade off the balances between these somewhat competing ideas about where they see the future of DELEG going. And I think that's going to be an interesting challenge.
Yeah.
But this is a very exciting idea. Yeah. I'm also a little bit concerned that we may have some concerns that we might go into unearth even more problems about zone cuts as we had before with DNSSEC stuff all those years ago. I think we might go through all that yet again.
Right.
But we'll see how that happens as things progress.
Right. Thank you, Jim. Actually, one of the things I did want to mention was, besides soliciting your input on GitHub, if you are an implementer or other operator who's interested in this, providing that constant impetus for moving forward. It doesn't, have to be any kind of weekly thing or whatever, but showing up every once in a while and saying, hey, I really like this. I'd like to see it implemented, or perhaps start implementing yourself, is tremendously valuable. I am encouraged that, much like when DNS over HTTPS was approved, that it is likely to see at least useful adoption on relatively short time frames, even though we would expect the old method of delegations to pretty much be around for the rest of our lifetimes.
Sorry, I need to come back about that. First of all, I'm an old fart. Jim Reid again. Old fart is, please don't do stuff in GitHub. We have a mailing list. That's what the ITF is supposed to do stuff.
For our document in particular, right?
Yeah.
But for discussions and right, 100% agree. Yeah.
Thank you for that. Yeah. The other point I was going to make is that this is potentially going to have significant repercussions across the whole of the DNS infrastructure and all the rest of it. I think we need to have perhaps more of we in the ITF are going to need a much more considered approach towards deployment and implementation. Specifically, with the example with DO, that was done and dusted effectively in one meeting at the ITF. And the implications of that later on, creating all sorts of layer 9 and all sorts of stuff, we have to be careful. We try to either avoid those problems for the future, or at least have a better understanding of what we're going to get into before we get into it.
Yeah. And I'd respond a little more, but I'm over time. So
Thank you, Theo.
Yeah.
So the next speaker is Martin Pels from the RIPE NCC, who will give an update about all the things DNS at the RIPE NCC. Floor is yours.
Hi, I'm Martin, and I'd like to talk about what we've been doing since RIPE 87. First off, we've built some things. My colleague Anand spoke here last time about our POP that we wanted to deploy for DNS in Tokyo, and that we had quite a bit of delays in getting hardware over to Asia. And I'm happy to report that the POP went finally live last month. We are in NTT building in Tokyo, and we're peering at JPNAP and Dixie. And the site is now carrying about 10% of our DNS traffic. So we're quite pleased with that. Then some other expansions we did is we added a few hosted DNS instances in Venezuela, in Kansas City, US, and in Indonesia. And we've been very busy with upgrades. We were running CentOS 7 on all of our DNS servers. This is going end of life and around July this year. So we have upgraded all of our auth-DNS instances to Oracle Linux 9, and in the process also migrated them from Ansible as a configuration management system to SaltStack. We still have a few backend systems to take care of, but the DNS servers themselves are all Oracle 9 now. Then sadly, since RIBE 87, we also had one outage. So to give a little background on that, we run a setup with a number of core sites where we have hardware routers and servers, but we also have several hosted DNS instances. These are single server deployments, either on VMs or on physical hardware. And each server obviously has a DNS server application, but it also runs a routing daemon that talks BGP to an ISP or to participants on an IXP. And the routing daemon has its own routing table with our Anycast prefixes that we advertise to the world, and the connected peering LANs and the routes that they receive from the BGP speakers. So what went wrong here is we nicely migrated everything to SaltStack. This went quite smooth, no issues there. But what we failed to do here is actually configure the SaltStack to not to use a specific routing daemon package version. So what happened is the routing daemon software that we use, there was a new release upstream. Our boxes automatically downloaded that and started using a new release. And this release actually introduced a breaking change where the connected routes were not imported in the routing table. So what happened was BGP routes we received could not be installed because there was no next hop. We were still advertising the Anycast prefixes, so we were getting traffic in, but we could not send any traffic out because the box didn't know where to send it. So this led to timeouts for resolvers talking to 8 of our 19 auth-DNS sites. We run multiple different implementations of the routing daemon, so it did not affect all of our POPs, but yeah, depending on where you were, you got timeouts. Yeah, we did a couple of things to deal with this. Obviously, we fixed the release pinning. We also made some changes to our alerting. We've normally, in this case, we only received alerts by email. We had made some changes so that we could also, in these specific cases, also get SMS alerts. And we're investigating if we can do automated withdrawals of prefixes if there is a problem with a particular hosted box. We are being very careful with this because we don't want to get into a situation where we automatically withdraw our Anycast prefixes on all of the instances and turn off the entire service. But that's something we look into for individual cases. Then I wanted to talk a bit more about the service side of what we run. So our auth-DNS setup is composed of 5 different services. We have pri.auth-DNS, which is the reverse DNS for all of the IP space that is handed out by the RIPE NCC, the reverse delegations for that. Then we have rar.auth-DNS. This is the secondary DNS for the reverse DNS delegations of the other RARs. This is a full mesh setup, so each RAR is a secondary for the reverse DNS space delegations of all the other IIRs. Then we have manus.auth-DNS, which runs our own zones like ripe.net. And then the last two are ccTLD and ns.ripe.net, about which I want to talk a bit more. So about the ccTLDs, this service is defined in the RIPE document, RIPE 663. It is meant for smaller ccTLDs that are not able to support their own full infrastructure. And we offer a service to them to be secondary for their zones. In the RIPE document, it is defined that this is only based on agreements with a fixed lifetime, so that we can evaluate and reevaluate if these ccTLDs still adhere to the criteria we have for this. And these criteria is that there are less than 10,000 delegations in the zone. They should not have more than 3 other secondary name servers providers. And they should not have any commercial name server providers, because we figure if they are able to pay for commercial parties to handle their secondary DNS, then they don't need our support anymore and they can be on their own. So when this document was written in 2016, we had 77 ccTLDs on the platform. And this has slowly decreased, and we're now at 30. The list is on the slide. And we expect this to slowly go down in the future, and as more and more TLDs mature. Then the last service I wanted to talk is ns.ripe.net. So how this works, this is a service for larger LIRs with a /16 or more IPv4 space. And what they could do is they could actually, in their domain object, configure ns.ripe.net as a secondary service and have us serve their zone. Now, this service has been offered for quite a while, but we see lots of problems with it. First of all, it's unfair to smaller LARs. As I mentioned, you need a /16 IPv4 to be able to apply for this. Not many LARs have that. The second issue is that it's a service that used to be something special, but these days anyone can run, and many do run DNS services for others. So we're actually competing with our members with this. And then there are various technical issues that we see. The biggest one is that we see provisioning failures where people configure us as we configure us as a secondary, and then we try to fetch the zone from the primary, and that fails. We see this for about half of the zones that are configured on this platform. So there's many brokenness. Due to time, I won't go into all the other technical problems that we have with them. Some of them are easier to fix than others, but addressing them would take a lot of our time, and this would still leave the non-technical issues that that is not for smaller LARs, and that we will be competing with our members. So instead, we propose to shut the service down. My colleague Anand wrote a Labs article about this in more detail. In essence, the timeline is that we want to stop accepting updates and new additions to the service from July 1st. Then the rest of the year, we will reach out to the existing users of the service and ask them to move away. And then in January 2025, we plan to turn it off. So on the list, we actually announced the end of service date as December 31st. We got some comments about that, that it's in the middle of the holiday period, so please don't do that. Our hope is that by December 31st, everybody has moved away, so we can actually turn off the service sooner. If it turns out that at the end of the year there are still some zones left, we don't mind waiting a couple of days and turning it off in January, if that makes people feel better. So if you have any comments about this after the session, because we're out of time, or you can send a mail to the list and let us know if you really want us to keep this. Come up with a good reason why, because otherwise we'll shut it down. Thanks, that's all.
Thank you, Martin. Yes, so the next speaker is Sandoche Balakrichenan, who will talk about energy consumption of DNS, measuring it.
Okay. Good morning. Today I'm going to talk about studying DNS energy consumption. Actually, I submitted for a lightning talk, but thanks to the chairs, they have given me 15 minutes, so I have some preliminary results also here. So what is the motivation for us to do this study? One, as part of a corporate social responsibility, the company that I work for is AFNIC, which manages the internet namespace for France. So we have engagement with the French government, which mandates us to study our carbon footprint and, if possible, reduce it. The second one is technical. So if you see, I have two references here. One is from the EPNIC site, where we see there are more and more encrypted traffic in the DNS. That's about 23% when I saw on 16th of May. And the second one is that, in the second reference that I have, there are a lot of research materials which demonstrate that when you do encryption, decryption, encryption, the energy consumption increases. So this is the study from Princeton, which demonstrates that while you do an SSL connection, then a normal UDP connection, the consumption gets increased. So from a technical view, we wanted to study these measurements. And if you see, there are many studies on web traffic, but none on DNS. So we thought that there is a research area that would be interesting to study. So AFNIC, the company that I work for, as part of its corporate social responsibility effort, has been quantifying its carbon footprint. So it has been working with its counterparts in Europe on a framework. So this framework is based upon the ISO 14064, which classifies into 3 scopes. So I have scope 1, 2, and 3. So if I want to explain it in a simple manner, if I want to drink a coffee, I need a kettle and a cup. The kettle to make the coffee and cup to drink it. So the energy taken to manufacture the kettle and the cup comes under the scope 1. So if you relate to the DNS world, the energy needed for having the hardware materials like the servers, the cables, etc., comes under the scope 1 category. The next one is, if I want to drink the coffee, I need to connect it to a electric cable and to make the coffee. So if I relate it to the DNS world, it is how much energy needed to have a DNS resolution. And the third one is the other supply chain activities. For example, the office, we have the employees to and fro commuting from office to the home, me traveling here to arrive. All these comes under the scope 3. And what AFNIC has been doing is that quantifying the scope 3 from 2018 to 2023. So if you could see, we were able to reduce the carbon footprint. And for 2023, for scope 3, our carbon footprint is around 625 tons of CO2 equivalent. And we divided by the number of domains that we have. For example, we have like 4.3 million domain names, and it comes to 147 grams CO2 equivalent. So this is the carbon footprint to host a domain name for a year. And if you relate it to layman term, it is like you're traveling by car for 600 meters. So what we want to focus here on is on the scope 2, that is how much energy is taken to do a DNS resolution. So there are some preliminary measurements that we did. So we wanted to do the energy consumption at the authoritative server, the resolver. We wanted to identify the tools and architectures needed for this because this is a new thing for us, and decide on the metrics to measure. So uh, as I said earlier, we focus on the scope 2. So it's the electric consumption for a DNS resolution that we wanted to study. And the units is in watts, kilowatts. And if we want to do over a period of time, it's in kilowatt hours. So where to measure? As a TLD, we have access to the authoritative servers from a TLD perspective. So we could do the measurements here. And we wanted to do at the resolver point of view also, but we don't operate a resolver. So what we did was that we created a laboratory environment to study that. So if you see here, it's on the authoritative server level. We connected hardware, the watt meters, to 2 of our data centers. And these watt meters study the energy consumption per second. And we have a VM where we collect this data, which has Prometheus and Grafana. So from this watt meter, we send via SNMP exporter this data so that we could have a graph on that. If you see for us, like our servers are using like 37.8 kilowatts per day. And for resolver measurements, we had a bare metal running a resolver on bind. And here what we did was that we changed the tool. We had a software probe here, which is called Scapander, to study the consumption. And we use this small script to generate the DNS traffic on a number of queries per second. So this is an initial measurement that we had. We had different types of DNS traffic from UDP to door. And we were sending queries per second. If you see this graph, what we could understand that it is linear up to like 750 queries per second. And after that, we see a burst in the TCP and dot. But that is not understandable for us why the TCP is more than dot. So we need to dig further deeper here. But as I said earlier, it's preliminary results, and we don't know what caused this, but we will do further measurements to see that it comes back again. So the work in progress, as we saw earlier, we wanted to study the different evolutions of DNS from a normal UDP to the encrypted traffic, and we know that it's quite impossible to completely study the DNS resolution because DNS is too talkative. But for that reason, we want to develop a mathematical model to estimate the number of packets and the packet size for these different types of DNS traffic. And we want to benchmark the mathematical model based upon real measurements that we have and approximate evolve this mathematical model so that we have an accepted confidence interval. Finally, to convert the measurements that we have into understandable terms, that is CO2 equivalent, as we did in the scope 3 earlier with the supply chain activities for the DNS. So this is a slide that I took from Vesa Drake's deep dive presentation. So this slide, just to demonstrate that it's quite hard to completely quantify a DNS resolution, because for one single DNS query, you have a number of queries being sent over the wild. So we understand that it is difficult to quantify completely, but so hence we wanted to do it in a simple manner, taking a lot of assumptions so that this mathematical model could be evolved. So first thing that I said earlier is that we want to estimate the number of packets for the different types of traffic. So simple mathematical model where we have with cache, we have like 2 packets, and without cache, we have like 8 packets, because it has to go to the root, the TLD, and the SLD.
Most typically just to the TLD.
Pardon?
Mike,
Most typically just to the TLD.
Mike.
Yep.
Go on.
Yeah. So these are the assumptions that we have. And for TCP with cache, if we go like we have like a connection phase where we have 3 packets and a closing phase where we have 7 packets, and we assume that the ACK is not piggybacked. So we have 2 packets for ACK. So the estimation is with cache is 11 packets. So if we go to the, for example, with dot and DAW, we have a DAW example here, just with TLS 1.3, TLS adds 4 more packets. So with cache and without cache, we have this calculation that is 23 and 29. So this is an estimation of the number of packets, but we have to also see the packet size. So that also has an impact on energy consumption. For example, for a TLS communication, we have X05, X509 certificates, the algorithms like RSA, ECDSA, etc. So that has to also be taken into account. So just for estimating the carbon footprint of a UDP packet here, we take some assumptions also here. So I have only the UDP example here. We take the MTU size of 512. For 2 packets, it's like 1024 bytes. And to get it to a understandable limit, we have to convert it to gigabytes. So we convert this 1024 into gigabytes, and from a sustainable web design framework, the energy consumed is the bytes transferred into 0.81 kilowatts hour per gigabytes. That is for website traffic. It is not for DNS traffic, but now we take this assumption and we multiply the number of for a kilowatt hour, and we come to this value. I'm not going to completely tell the value. It's around 0.00 something like that, 82944 kilowatt hours. And then to convert that to CO2 equivalent, this is also from the sustainable web design framework, where we multiply that into 442 grams per kilowatt hour. It comes to like 0.303666148 kilograms CO2 equivalent, which is very, very small. So I multiplied that for example, for 100,000 UDP resolution to see how much effect it has. For example, if you relate to how much travel by car, etc., as we did at the CO2 equivalent for our scope 3 estimations. So it comes like to 1.4 kilometer by car. So these are all assumptions that we had. So we have like, this is a study that we have just started. So we want to have, for example, the 0.81 value, 442 value for DNS traffic. So this is a program that will be going for some time. So as part of fulfilling the corporate social responsibility role, we have started to think about it. We are having forthcoming PhD programs with the 2 universities on focusing on this topic. And as we know that we don't operate DNS resolvers, we would like to collaborate with other parties. People at Tribe, for example, we also are a TLD. We don't have expertise in energy measurements or mathematical modeling. So that's why we have collaborations with the research universities, and we would also have your feedback. Thank you. I hope I'm at time. 2 minutes, okay. Questions? Okay.
Hi, Lars Lehmann from NetNode. Thank you. I think this is important work, and we as community, and this is in the case of you here, need to start to work with this. But it is an enormous field, and there are such a gazillion of variables in here that it strikes me as very difficult to reach any useful results at an early stage. But if we don't start to attack it and start to work with the problem, we'll never have any appreciation at all. But there were some assumptions in your presentation there that I felt were quite far from what I would assume is reality. So as long as you make it clear when you present any results of this that this is based on a very strict and limited set of assumptions, I think this is valuable work, because that will give others a reason to work with other parts of this, and slowly and carefully we can start to build a better picture of the actual energy consumption. Thank you.
I do completely agree with you. So it's something that has just started. So there are a lot of assumptions here that is not correct. I completely agree with you, but I think step by step we will dig further and get some maturity.
If no one begins, we'll never reach the goal. So thank you.
Thank you.
Hello. It's more a remark than a question. Sorry, I'm Alexis Lamer from France too. And it's more a remark than a question. This kind of evaluation of CO2 equivalent is interesting, but it don't take into account that when you design a system, you have both some hardware, that you use for a certain capacity of infrastructure, and by doing like in economy analysis on the small part from each query, don't take into account that when you both some hardware, this hardware have more capacity to do stuff, and when you reduce the footprint of one query, you don't reduce the footprint of the whole system. And in my opinion, this kind of evaluation that is granted by our local administration like ADEM to see each query, each usage, is not the best way to try to reduce its footprint. In my opinion, we should evaluate the system as a black box. Which hardware did I need, which software did I need, and how to limit the quantity on the macroscopic scale instead of the microscopic side of reducing the query.
I do agree with you. You know, the consumption depends upon the hardware materials, also what type of resources are used, whether it was resource done by energy, by wind, or by fossil fuels. So all this to be taken into account, but that comes under the scope 1 category. Under the scope 2 category, you know, what we would like to have a look, it's just assumptions here also in the future, is that if, for example, we have QNAME minimizations in the DNS, whether such things could be used to reduce, for example, how much traffic goes out, and also, for example, to see, because most of the servers are over provisioned today, can we reduce it so that it can be, it reduces the carbon footprint. So these are all the objectives that we have. These are all, as I said, hypothesis, and currently we have to dig further. So I agree with your point.
Thank you.
Presentation.
Thank you. I'm really sorry I have to cut the queue because we have too little time. But thank you, Sandoche. That was wonderful. So next up are Shane, Kerr, Babak, Farooqi, and Dave Knight. You know, Shane has been working with a whole bunch of other people on the Dissolver best practices or recommendations from the IPNCC. And this is sort of a panel discussion, I guess, discussing how people in practice are doing those best practices or comparing it. Shane?
So, all right, hello everyone. So we're going to do a kind of a discussion here. So the slides are very light. Don't worry about it. We'll get really into it. So the idea is that we had the RIPE community built a task force to come up with the recommendations for DNS resolvers. We published that document officially May 1st. And so now what this discussion today is not going to be a detailed analysis of that or a review of the history of it or anything like that. What we want to do today is I talk to a couple people who work in organizations that run large-scale DNS resolvers and do a kind of reality check and see, well, we've written these recommendations based on what we thought were good ideas. What are we actually doing in practice, and how does it work? What things are interesting about the comparison, and so on. So that's it. Hopefully it's interesting. This is kind of what we're going to talk about here. Yeah. So who are we? My name is Kerr. I currently work for IBM, where I came across as part of the acquisition of NS1. We do manage DNS. And I was the chair of the task force which created this document of recommendations for DNS resolvers. And then I'll let my colleagues here introduce themselves. So, Babak?
Yeah, I'm Babak. I'm the director of operations at Quad9. So we run one of the largest DNS resolvers around the world. We are operating in 119 countries in 236 locations. And yeah, this is why we are here to discuss the best practices document. So handing over to Dave.
Thanks. Hi, I'm Dave Knight, architect at Ultra DNS at Verkara. We also operate a public resolver, so I can talk about that. But also we operate our internal infrastructure resolvers, and we use the resolvers of others when we're in a cloud environment. So when I've looked at this document, I've tried to think about it in terms of all of those things. But yeah, for our public stuff, we do that. We have a completely open public resolver, but then we also have, white labeled resolvers for paying customers, which are accessible only to them. So we have quite a range of different uses and implementations of resolver stuff to talk about.
Great, thank you both. Right, so we just went through the document together. We'd all read it previously. We went through it together yesterday and just picked out a few things that we find interesting. So the idea is we're gonna talk about this and just mention how we do things, what we found interesting about the recommendation. And if any of you in the audience have anything you want to say, please hop in. We don't have a whole lot of time here, but our goal is to just find interesting things and dig into it. So if we run out of time, we run out of time. I think it'll be great anyway. So first thing that we had was, we had a bit of a discussion in the document about multiple implementations. And so the idea is if you run a single type of software, then you're vulnerable to 0 days. But there's also a cost to that, of course, because you can get around that by running more than one implementation, but then you have to maintain different versions. And that also introduces chances for instability and problems. So I don't know, I think Dave, you were the one that wanted to talk about this most.
Yeah, this is kind of interesting to me because the document suggests, it is a good idea to have multiple implementations. But, in our experience, the kind of vulnerability which renders, a single implementation immediately unviable to the point that you would definitely want to switch to another is reasonably rare. So, there's a kind of cost benefit analysis that you need to do there, because obviously running multiple implementations introduces operational complexity, makes things a bit harder to debug, or at least more surprising. And then, then you would have to think about how do you run this? Are you keeping a second implementation as a backup, or are you running them active-active? Because one of those makes it more complicated, and then the other one means, oh, is the one that we had as a backup, we forgot to add this to the configuration. So now when we switch to it, it doesn't work the same, or, so certainly what I would suggest is that you want to carefully consider this before doing it.
Yeah, I have to slightly disagree with you because at Quad9, security is our top priority, right? And then this is actually one of the trade-offs that we are aware of and would like to take. And this is why we have 3 different implementations, just in case we run into a security issue, like a 0 day with one of those. We don't want to take any chances. We just want to be able to turn this off and then let the other resolver software to handle the load. And that's why.
I also found you mentioned something yesterday that I found quite interesting, which is that one of your implementations just causes more operational issues. And that's the kind of thing you would only discover by running multiple implementations and comparing them. And so you might end up wanting to pull one software implementation out of service and either replace it with something else or just leave it out. So that's something you can only do when you're running multiple implementations. So, yeah. You have anything else? Okay, good. Oh, Jim?
Yeah, Jim Reed. Sorry, I have to disagree with what you were saying, Dave. I think it's important when you're running key services for a large installed base or expensive argumentative customers who've got very demanding requirements, that you should have multiple implementations in place and probably have a set of circumstances where you've got different sets of named servers providing the service, running different implementations at the same time, and you're switching between these almost as a matter of routine. So that the event there's some kind of catastrophic packet of death, you can switch all the implementations away from the exposed platform onto something else without having to figure out, oh, what configuration file or what magic button do I have to push to make this happen? If you're doing those things as a matter of routine, it will always just click into place if and when something really badly goes wrong. And while you're right to say there's a trade-off between how much the cost of having had these multiple implementations, there's a cost-benefit analysis to be made. I think the problem of those analyses really is you're looking at it purely from the, I think a lot of people look at this primarily from the point of view is running the DNS service itself. There's not a bigger understanding of the bigger operational risk for the business, reputational risk for the business. I would say, for example, taking Ultra DNS, great platform as it is, but if it was to fail for some reason, the public perception is Ultra DNS is crap. And that's a big business risk for you.
Sure, absolutely. And yeah, I mean, I guess to respond to that, we were thinking about this in terms of this document, and this document isn't just telling people how to run a big globally anycast public recursive service. Yeah. You know, I mean, people who run a small enterprise network might read and benefit from this document, and you know, their needs are going to be at least a little bit different from the likes of us. So you know, so I'm not saying don't do it. I'm just saying think about it before. Think about the bigger picture before you make a decision.
Exactly. I mean, I think the question really that has to be put to people is that if your DNS goes down, what's the reputational cost? What's the actual financial cost to that? It's not just in terms of, well, I can't send emails or I can't get cat videos off Google.
Yeah. Thank you.
Petr Pacek, ISC. I have seen a deployment or two because we provide support for DNS, and I think the point of having competent people who can handle multiple implementations is a very important one, because if the operational staff is confused, multiple implementations is not going to help, because if they have trouble configuring one, they will have much bigger troubleshooting 2 or 3 or you name it. So I think that's the balance. And I mean, I agree with, you know, everything which was said. It makes sense on paper, that's perfect, but it needs to take the operational reality into account, because different organizations work differently. And yeah, I have a list of SIM cards I'm never going to buy because of that. So
all right, cool. Right. Next topic, in the document, we have a breakdown of different ways you can deploy your service. And we kind of present this contrast. One option is doing things in bare metal, you run all your own stuff, and the other option is putting things in the cloud. And then that was kind of our suggestion. But then Dave, maybe you wanted to talk about what your thoughts on that are.
Yeah, really just reading that in the document, it kind of paints this picture of, well, you could do things on bare metal, that's how you get performance, or you can do it in the cloud. And there was really sort of it doesn't make it, doesn't suggest that there's a lot of scope in between that. And, you know, for ourselves, we run all of our resolver workloads in virtual machines, always where we control the hypervisor and the hardware. We can, you know, the performance difference between running them in that and on the hardware is negligible. You know, we can do the CPU pinning and we can attach to the network with SRIOV. So there's, you know, there's no real difference for us. And so that was kind of just something to point out, that the document is making it look like there's a strict separation, and really there isn't. And, you know, one other thing that I was going to suggest was, you know, where we do things in the cloud, we use a cloud that specializes in delivery of IP anycast and high volume UDP services. And, you know, perhaps this is out of date, but we don't imagine that we could run our services effectively in a big public cloud. So we deliberately have chosen cloud environments which are well tuned to the kind of things that we're doing with DNS. But we don't run things in one of the sort of big 5 clouds.
Yeah, I'd like to add that, well, also cloud is available in some hotspots, right? They're not available everywhere. And part of our mission is to be present to as many countries as possible. And well, cloud is not on those countries. And also we'd like to have, for security reasons, we'd like to own the hardware to have more control. So that's why we prefer to run on our own VMs, on our own metals.
Great. Clouds are bad. Good. All right. Next topic. High availability. I don't even remember what we were discussing here. Sorry.
Yeah.
Help me, Dave.
See, this is why I have the notes.
Yeah.
Now I can remember.
Planned ahead. Yeah.
I think there wasn't anything terribly contentious there. We just, because with this document, we're not standing up here trying to pick apart faults in it. There's a lot of things in there to like. It's a good document. And if anything, we kind of need to apologize for not having made any of the negative comments during the formative stage of the document rather than after it was published. So this, I think, was one of the ones where we just wanted to acknowledge how we actually do it. Because in that high availability section, it suggests various different options. And I think both of us, we do it with IP Anycast, and it's Anycast all the way down to the server. And yeah, I had other notes, but I don't think it's really relevant.
Yeah, so I remember now. There was a distinction between how at each site you guys, how the different resolvers do high availability. So I think you do BGP within the site. And
yeah, that's right. I mean, so we use IP Anycast in V4 and V6, and that is all the way to the server. So each individual workload is running a BGP speaker, which advertises service prefixes from the server, which are then aggregated in a router and then advertised in covering prefixes to the internet. I don't know.
Yeah, almost the same. I'd like to add ECMP to the stack. And the fact that, well, we run multiple metals in our hotspot locations, we run multiple VMs in them, and we run load balancers in front.
Yeah,
so
I think that for me, that was a key difference, is that you have a load balancer versus not a load balancer. Yeah. And
yeah, I think the one last note I had on that was one thing that we do where we use a cloud environment, because that's further from our control, we use covering prefixes for the services that we advertise there, so that in the event that there's any problem with the command and control of that cloud, we can unilaterally start advertising more specifics and pull all that traffic back into our own network or into our DDoS mitigation network without needing to touch the command and control for the cloud. So it's kind of just a little security mechanism that we built into the routing, which protects us from any failure of a third-party operator.
Cool. All right. The next section, we have recommendations around ECS. This is eDNS client subnet. And so the way it works is that a resolver, when it sends a query on behalf of an end user, can include information about the end user's IP address. In principle, the idea is this lets the authoritative server provide better information in its reply. For example, geolocations directing to a different service and things like that. It does have privacy implications as also operational implications. So we didn't make a strong recommendation one way or the other, I believe, in the document, but it was important to mention. And I think both people were interested in it. I don't know, do either of you support ECS?
We don't do ECS at all. And yeah, my one comment on the document is maybe it could have said a little more to make you think about the privacy implications of it. But yeah, we don't do it.
So it's a double-edged sword, right? So some people like it, some people don't. I prefer it when I watch HBO, but pretty much for nothing else, right? If you use 9999, by default ECS is disabled. But if you like to use ECS, you can use 999.11. So we do both.
Yeah, and I think there's also something which we also didn't mention, which is that the more widely distributed your edge is, the less useful ECS becomes, because you're much more likely to get to a resolver close to you, which is going to give relatively good results anyway. Oh, Peter, you have something to say?
Petr Špaček again. And also on the other end of the spectrum, if you are concentrated in one place, you don't need ECS either, right? Because there is just no point.
True.
So, and that's something which I think we have trouble to explaining to not really experienced operators, because they just see, ECS, we want this feature because we want it.
Yeah.
And that's it. And like most of the time it's not needed because there's not a lot of people which are distributed all over the place. So
yeah. Although if you're doing your resolvers in big clouds and there's only like 10 locations in the world, maybe that's the sweet spot. I don't know. Anyway. All right. The next thing is we had a little bit of text around RPKI. So this is route authentication-ish stuff. Dave was chastising me yesterday for calling RPKI route authentication. And it's questionable how much benefit this actually provides in the DNS context. So maybe we can talk about how you guys implement that, or don't.
So we sign, but we don't validate.
Validation is so there's two parts. Yeah, validation and publishing. Yeah.
But that's on the roadmap. We see a huge value in also validation because we don't want to just run into this all sort of BGP trouble. But that's something that is planned for before end of this year.
Okay.
Yeah, we are in the process of publishing signed ROAs for all of our address space. All of our V4 resolver stuff is done now, and we're now doing the V6 ones. So we should have that finished in the next few months.
Shame on you for doing V4 first. Shame.
There were reasons beyond V4, V6 for this order of events. And yeah, we recommend it strongly. You should definitely do this. I had another note on this. That was it. We don't do validation, but that's because we're largely a transit-centric network, and our transit providers are in the main mostly doing this already. So it's not necessary for us to do it as well.
Yeah, that makes sense.
Hi, Tail. One of the things I'll observe is that, it's mimetic that, it's always the DNS. But some of the security problems that the DNS has been blamed for have actually been route hijacks. And so it is significant in that context. I mean, one of the hard sells on DNSSEC has been, that, you're adding actually more complexity to your system for limited protections. Well, route hijacks are one of the places where you really get your protection. So, if you're indicating that this is supposed to be a signed zone, but the fake servers can't answer for it, then yeah, it's good. So I'm very much in favor of still enabling route authentications.
Yep. Next one is about, we recommend, we have some language about how you handle negative trust anchors. So negative trust anchors are when you're using DNSSEC and you're trying to resolve an answer, and the people maintaining the authoritative servers have messed it up somehow. They haven't re-signed their zone, or they've put the wrong key in the parent or something like that. And you have a high confidence that it's actually just operator error. You can put something in your resolver to configure it and say, turn off DNSSEC for this zone. It's not a great solution, but it's also needed in some cases. Although maybe less now than it used to be. So maybe you want to talk about.
Yeah, but my response is very quick, which is we looked around and like we could deploy an NTA. We don't know that we ever have.
Yeah, I can tell you that we did that quite a lot. So we had a recent incident with one of the CCTLD operators having some trouble with their DNS key, and we had to immediately, after confirmation with them, to deploy an NTA because the whole country could not open their websites, like the banks or government websites. So that was one of the use cases, but we should also make sure that we remove it quickly after they're back online. So that's one of the things.
Yeah. I guess that's it. All right, so the next thing is we also have text in the document about encrypted transport. And this is encryption from the client, the end user, to the resolver. And our recommendation was you should enable at least one. And we didn't specify what you should do because that's going to depend on what you think your end users are going to have and things like that. But the three basic approaches that are available today are DOT, which is DNS over TLS, which is sort of a plain encrypted channel, then DNS over HTTPS, which adds a bunch of unnecessary and completely pointless wrappers, but people like it in the web world. And then there's DOQ, which is like the great future that's going to save us all, DNS over quick, but that's not very widely deployed. And yeah, so that was our recommendations. I know Quad 9 implements 2 of them now, or just 1?
Well, 2 plus 1. There's one that's not on this list. We also do DNSCrypt because some people love DNSCrypt.
Ah, yes.
And to encourage you, to encourage you to implement encryption. We are seeing constant increase in the traffic at a scary pace. It's scary for us as operators because it needs more hardware to encrypt and decrypt, but that's great for the users. And we are seeing maybe a few % increase like every month.
Oh, wow.
Yeah, and that's huge.
Yeah, we have some dot and do on some of our resolver addresses. I think all of those which are, you know, in commercial relationships, the free public open service doesn't have it yet. And yeah, that's something that we're working towards.
Okay. And are either of you going to be looking at the quick stuff either?
Yeah.
Oh, okay. Maybe we'll have another report in a year or so. This one is we make a recommendation that you support NSID, especially if you use Anycast, because otherwise you send a query and it comes back and you don't know where from. And I think both of you have strong feelings about this, right?
Yeah, I certainly do. I think that whenever you run, you know, an otherwise hard to identify service, particularly Anycast things on the internet, it is so helpful to debugging to make it easy for users to identify it. You know, not just when they're trying to solve a problem, but also, you know, for an Anycast service, the user kind of wants to know, is this endpoint that I'm talking to reasonably geographically close to where I am? And, you know, so with that in mind, you know, the documents, I think the document suggests that, you know, it's typical, or, you know, it's people often use IATA codes, you know, so airport identification codes to identify a node. Which I would suggest IATA codes aren't great because they're often not human readable. So for that thing where a person using it wants to just see, is this near me? But maybe they can't tell if it is or not just from looking at an IATA code.
Dave lives in Canada and they broke their IATA codes by putting a Y in front of everyone. So.
Yeah, Canada makes no sense with its airport codes. So we use UN low codes, which have a country code and a more meaningful name for a city after it. And also with IATA codes, not all locations have airports. So, you know, I deployed Anycast nodes in a place where there wasn't an airport in the country that we could give it a name for. And another thing to note on the identification stuff, you know, security people will often get upset about, oh, we can't put the name of the server in a way that's published because that's bad. It's like what's in the identification doesn't have to be a domain name. It's just a string. As long as there's meaningful information in there, it's useful. You should definitely always do it.
Yeah, it really depends on the scale, right? So when you're operating more than 1,000 resolvers in more than 100 countries, and a user approaches you, asks you about a performance issue, first question you ask them is that, which one? Like, where are you located? Which resolvers you're hitting? They don't know, so you have to ask for the NSID, and that's what we do. And we actually put the host name in there because that's helpful. And we don't see any security threat in doing that.
Yeah, cool. We're running close. We're running out of time. I think, yeah, we had a lot more things we wanted to talk about. I will pick just one at random, maybe stir up a little controversy as we go into the break here. We have a little bit of text discussing DNS cookies. DNS cookies are kind of a light way of getting some assurance that you're talking to the same user to prevent DNS reflection and amplification attacks. So at my organization on the authoritative side, we don't support it. I don't know, do either, I guess none of us support DNS cookies.
Well, we do. Yeah, it's fun because, well, again, it's one of the things that some people like, some people don't. So we're like, if you like DNS cookies, just use 999.11. We support DNS cookies there, but not on the other resolvers. So we give everyone, you know, choice.
Okay. Yeah. Yeah.
Yeah, very little to say. We don't currently support DNS cookies. We did have a look and thought, oh, it seems reasonably easy to enable this, but we have yet to find the motivation to get it done.
Andre?
Andre, I see. If you don't support cookies, just make sure you don't break if you get cookie. Please.
Oh, that's fair. Yeah. All right. Well, we're out of time. Thank you, everyone. We're around for a few days, so you can come and talk to us.
So let's start on time. I'm Peter. I'm the chair with you here for the IoT session. And so there's another Peter. So we made it simple here in the work group. We are both Peter. I'm Peter Well, and running the session here. Peter Steinhäuser. So he's on a business trip in US. So he hopefully joins us here now because 4 o'clock in the morning for him. So I hope that he's enthusiastic enough to be here on time. So we want to start with a little housekeeping. So first of all, just going to the, I have a clicker here, so let's try it. Okay, so we are on the housekeeping. We have 3 talks today, so therefore the schedule is quite full. So the first one is Erich. Just was a little nervous because I did not recognize Eric, but he is around as well. We have Poonam. So for her, it's the first time being in a RIPE meeting, and then also to doing a presentation for us. And last but not least, Judd. So is also around with us, and so he wants to give us some updates on the RIPE NCC IoT because there's some interesting things which we discussed last time in Rome, and now getting an update. What we're also looking for is the co-chair selection. So I did a mistake in the email group. It was writing election, so it's definitely a selection. And what we are going to is so that we use the Meet Echo, and I will give you a short introduction to this. First of all, from the housekeeping, so we have validated the RIPE 87 minutes. So it was distributed on the email list, and so there was no objection to this. And of course, so we have also this meeting under the code of conduct. So if there's any a discussion, so please let's take under these conditions. On the minutes from the last meeting in Rome, as stated, it was posted to the group. There was no further discussions on it. We have also published the links. So with this minutes of meeting is now finally agreed. So today we have also then people typing again the next minutes, and let's see how that goes. So if you have any questions, as for all other sessions, so we are now in the middle of the RIPE meeting, so you might have already experienced. So go to the mic, ask a question, say your name and your affiliation, which is then then noted. You might either speak for your organization or for yourself. Just to mention on remote participants, so you can have audio video question, stenography, you can go for chat. And for the poll, so we are opening now a poll, how to go to Meet Echo. So you got a link with your registration here in the meeting. And this is a unique link for you. So you can go to Meet Echo and open the chat, even if you're here in the room. So there's a simplified version which helps you here in the room. And this is while we then open the poll now, you can either use your telephone here, your laptop, and especially, if you're online, then you have also the chance to put your choice on the 3 candidates. So we have David Schweitzer, so he applied, as well as Peter Steinhäuser. So he's my co-chair now. He asking for a second round. And we have Andre. So sorry for the spelling mistake. It's a Y, should be a Y on Andre. So he also sent his details into the email group. You had some time to do some discussions there. And so we open now the Meet Echo poll that you can give whenever during the meeting your voice to one of the candidates. We will then visit the results in the end of the meeting. So, if there's any question on the procedure. Okay. So I'm happy then because we have a quite tight schedule. So we have scheduled roughly around 25 minutes for the presentations. And so the first one is from Eric. And I'm happy to welcome Eric here directly in the room. You may know how this works.
Yes, I do. Fully experienced.
Stage is yours.
Guten Morgen. Goedemorgen. Good morning. For those who visited RIPE meeting in Rome, I had there a short presentation about the topic matter. And in the meanwhile, we promised, in this case was with Peter Steinhauser, we promised that we would go a little bit more in depth. And a few weeks ago, there was the Broadband Forum spring meeting in Mainz in Germany. And there was as well a very interesting link between the data model, so in this case, the TR-369 and the TR-181, and the IoT world, in this case, matter. So what I do for you is that I give you some slides already here. I've seen them in Rome. And some slides are sent by me from the Broadband Forum and give you an impression what's happening over there and where's the link between the Broadband Forum and the RIPE community as we are here. Some words, who's AVM? Make it very short, make it very simple. We are a manufacturer of the well-known German Fritzbox. You'll find them in Europe. We have products for DSL, cable, fiber, and mobile networks like 4G and 5G. So that's the introduction. I said, why I'm here? I'm a generalist. I'm not a specialist. But anyway, I have a deep role within the company as AVM, looking to what we need in the international market. What are the directions we see of the internet world? In this case, from the already mentioned technologies as well from the IoT world. That's my role. Stepped in within the Broadband Forum in the Executive Advisory Board. Because for AVM it's very relevant to be on track what is happening there on the standards and all the TR-369, TR-181, TR-69, you name it. That's very relevant for us. And last but not least, AVM is building products, including more and more IoT solutions, and we have to do something. So that's why we are very keen and very interested on the feedback you're giving to us here direct on the RIPE meeting together with one of my colleagues, or later on via email. And I keep it as a surprise. I said in Rome, yeah, we do have Matter. That's true. We implemented Matter now. It's running as an, we call it in-house test. So employees of AVM have the ability to use the Matter technology and looks quite promising. But still, we are in the beginning of this stage of this product. So we still need feedback from our colleagues, but as well from the community. If you look to the Broadband Forum and how they react and what they do, they have cooperation between several companies or organizations, in this case, the IETF. So there's feedback coming from both sides. It feeds into groups like we do here and implement those things in the stacks as we see. If you look to what's relevant here, and this will give you more inside look, we have some things, the TR-181, the TR-369, the USP, certifications, things, and so on and so on. But let's step further. Oh, sorry, some mismatch. What is USP? USP, and I give it in my own words, USP is a solution where you can monitor and control devices. And define devices, that's very wide. It can be, in this case, routers as we built. It can be ONTs. It can be the IoT devices. It's more or less a very broad spectrum of equipment. Nowadays, mainly used for Wi-Fi management, Wi-Fi control, and setting up the first connection of an internet device. This can be done in two standards, as I already said, can be done by the TR69 standards or the TR369 standards. It gives a lot of opportunities, it gives a lot of possibilities. And I remember years ago, there was a document also coming from the IoT Working Group for security, how to control an IoT device. And in that, let's say it, I hope I pronounced it right, this draft document, there was as well 369 as a standard. And also I believe 369 USB is the standard to communicate to devices without implementing all software from all foreign vendors into your router products. So we use, as well as AVM, we use 369 as the international common standard to communicate to our routers or our CPEs, as well to the equipment behind the CPE. And from AVM point of view, we think this is the right approach. This is the right approach to go forward, because it's a standard and is well known and is used by a lot of ISPs in the world. Okay. The interesting part as well is a question. As an ISP, let's say nicely, do I want to know which type of equipment an end user is using in their home? Is this relevant for me? Yes, no. Is it a security topic? Yes, no. And when I'm doing this, how to do this on a standard way? If you made a decision, yes, I will, yes, I do, then TR181, the data model used by the TR369, is, from our point of view, the right approach. What do I like to see? I like to see a map of the used equipment, where it is, how it's connected. As already said, I need to know and I want to see the Wi-Fi quality, because that's the main reason why a customer is calling his help desk from the at the ISP. Internet is broken, and as we all know, it's not internet broken, it's one part of the connection what's broken. And the USB gives you the ability to look and to control what's happening, what's looking at the inside world of this homes at the customers. Moving a little bit, let's say, already said, I want to connect those worlds. Yeah, Matter is something I gave a few slides last RAP meeting in Rome. So sorry, a little bit of repeat, but anyway, that's what we promised as well at the RAP meeting in Rome, because there came some questions. Matter is the protocol used for smart home, for controlling smart home on the standard way. If you all are aware of it, and nowadays you need an app from every vendor to control your lights or your climate system and so on. And Matter looks very promising to give a standard by controlling, or which you can control all your type of IoT devices. Matter is something what popped up by the big vendors. The big suppliers built it. There was a delay. Do we implement this? Do we go forward? Google is very active on this element. And as an own experience, like I say, it looks very promising. It looks very easy. So what I have now, just an example, on my mobile phone using Google Home, I can control all the Fritz device, because at AVM, we decide to use the protocol DELEG for controlling our IoT devices. And with DELEG ULE, it's not the most, it's a well-known standard for controlling device. But anyway, by implementing Matter, now I can control all the stuff from a Matter point. And this opens the world, not only at AVM side, but as well at a lot of other vendors who are doing exactly the same. That's why it's so important that the interop between the several devices is already there. You can use it. And we hope, not really sure, but I think and hope that this will be the common standard. It's not really 100% clear that it will be the standard, but as already said several times, It looks very promising, and I think it will be the standard for a lot of vendors in this environment. Some technical slides, because I learned here, but thinking you like to know it. Okay, TCP, UDP, IP version 6, and the lower layers based on layer 1 can be Wi-Fi, Thread, Bluetooth, and a lot of other stuff. And with this, you control. As said, and I already promised with Peter Steinhauser, if wanted, we can do an in-depth in between. Unfortunately, that couldn't take because of very tight schedules on all sides. But anyway, if there are some questions, that's what I could promise. Peter said we can do it as well. But as already said, but what has USB to do with Matter? Where's the link? And the link is that with the data model TR181 and messages from are implementing more and more IoT. So in this case, you can use the standard 369 data model by controlling IoT devices, including the Matter devices. And that's why, again, there is a cooperation between the broadband forum and the CSA. CSA is more or less the company behind the whole Matter stuff. How to do it, what to implement, and how to implement all those stuff in the current data model, in this case, TR181. Matter, first of all, we think, as well as from AVM, it's relevant, but be careful. We are still on, do we want to know, again, I'll repeat the question from the ISP side, do we want to know what's used internally at the end customer's home? Do I want to control? Do I want to see all things are happening over there? So from my point of view, there is still some, how do you say it? Coordination needed to look and see what do we implement in the data model so that we can have control or only just monitoring and so on and so on. So there's still some work in progress. And today I received the broadband forum information about the new data model, and I saw there are still some topics that they're working on. As already said, there is already a work done. So it's in the Matter interface is implemented in the model. Thread technology, let's say this is the layer 1 technology for communicating, is implemented. But as already said several times, we're not there. It's still a lot of work to do, and we still need some feedback. Is this the right way? Is this the right direction? Or do you say, please go away? This is not the right direction because X, Y, Z. Let's say it very nice, and I'm Dutch, so I'm not really well known as political correct. The cooperation between the CSA and the broadband forum is interesting. I leave it that way, but anyway, it's very complicated. But anyway, both organizations think that is the way to go forward, and that's the way they think we have to cooperate with each other. And as already said, I'm repeating myself, USB has the right cards to do it. So, and that's also one of the reasons why I'm doing this talking here. We need the feedback from you, from the audience, from the RIPE community. And as well on the broadband forum, they do more or less the same sessions I am doing here to collect the feedback on several organizations and to see, okay, how we do it, is this the right thing, and so on and so on. What's happening? If you like to travel, the broadband forum has the next meeting in South Korea, where it'll be again on one of the topics on the agenda. And there is the broadband forum is also town hall meetings, and town hall meetings are meetings about the whole new technologies, new things, and people can let's say promote their solution, their things, their future-proof things about new things and new technologies. It's very interesting. They did it as well in Germany and Mainz at the Broadband Forum Spring meeting. If you'd like to know more, I have some links for you where you can see all the stuff and what's happening over there. I'm here with 3 of my colleagues, so we're open for questions if you like, or at this moment. And yeah, that's more or less it. I want to thank you, and I hope I give you an overview of what's happening and why it's so relevant for the industry. Thank you for listening. Any questions?
Hey, Igor Ejibo. I have a question about the technical scheme you showed. There was a layer of IPv6, but is it going to also support the IPv4? Because like a lot of IoT devices, such as Zigbee and stuff, only do IPv4 from what I recall.
That's correct. I have to look to my right side, but as far as I know, it's completely, the communication is completely done using IP version 6, so no IP version 4 in this case.
Okay, thank you.
Other questions? You're all afraid of me.
So there's one question in the network from Martin Botterman. For meta developments, has there been a privacy impact assessment, and or is there any, at least a commitment to minimum data set, RE personal data?
Yeah, that's exactly the $1 million question. That's exactly the topic where I was aiming on. As far as I know, and give me, as already said, my own impression, if you are on a data model that the system is communicating with the devices, it's communicating with the devices. So there should be an opt-in solution, and that's more or less the same what we do in the CPE, that when the customer is activating his device, he receives a message, do I allow the operator to communicate with my device, yes or no? From my point of view, the next step will be exactly the same, that you as an end customer have to make a decision. Do I allow that the operator can and see and control my IoT devices? Yes, no. I think this is the most, secure is not the right word, but the most common case what will happen. We all know that most of the customers don't read it and say click yes, yes, that's the normal use case. But anyway, you have to do something, and it's exactly the point of view how I look to it. You have somewhere to allow the operator that he can see what's happening in your home. Good question.
So there's no further question on the internet. Any further question here in the room? Okay, seems to be not the case. Eric, thanks for your presentation. I think you're still around, so yep. If later on somebody has a question, you may give you take a coffee and doing some discussions on those.
Thanks a lot
so much.
All. Thank you.
So we have a few more minutes gained. So I want to ask the second presenter, Poonam, to so your slides should be there. And presenter, and so you have a little bit more time. So
should I start? Hello everyone, good morning. I am Dr. Poonam Yadav. I'm assistant professor at University of York, UK. And today I'm going to present something which we just heard from Eric on Matter, and something more related to Matter. This is called Threat Communication Protocol. And I'm going to look on the vulnerability specifically in some of the communication protocols in IoT. this is kind of work my team at York is doing, and our work at the university is funded by UKRI EPSRC, Department of Science, Innovation and Technology, under these different projects. So before I'll start, I would like to introduce my group, which is called Sistron Lab, which consists of 15 members at the moment. One of my PhD students gave talk yesterday. He's the end of the here. And the focus of our lab is to do systems and networks interoperability. So we do understand interoperability of the systems is quite challenging, and sometimes this is not like very lucrative research from an academic point of view, but because we are a system researchers, it's very important to make a system more resilient and robust. And we look this from a different perspective, for example, communication, resource constrained devices, internet architectures, protocols, security, and finally, from machine learning point of view as well. Specifically, when you have a system already and you plug into a new, say, new protocol or new machine learning algorithm, what is the impact of that on the network? What is the impact of that on the system security? And that's what we look at. So going forward, today I'm presenting one of our project called Safety Net project. And in this project at the university, we look from different work stream. One of the core aim is to build secure and resilient IoT ecosystems, and we specifically focus on smart home and home IoT ecosystem. So the first stream in this one, we look at the vulnerability in protocols, for example, Zigbee, Thread, Bluetooth, NB-IoT, even cellular networks. We also investigate at IoT device fingerprinting, for example, identifying devices uniquely or a similar kind of devices in the network without looking at the IP addresses of the packets. So the whole idea is how we can identify IoT devices based on the behavior of the devices in the network. And when we talk about behavior, we look at different parameters in the whole networking stack. It starts from physical layer, MAC layer, networking, application layer, and so on. Sometimes we join these parameters from different layers. And once this fingerprint is created, we can use this fingerprint to detect the abnormal network behavior of the device when a device is connected in the network. This abnormal behavior can be due to various reasons. For example, it could be the case that the device has been attacked and behaving differently, or it could be the case device has some internal problems. For example, it's a faulty, or some of the sensors or communication chip is not working as appropriate. So these fingerprints which we create could detect different kinds of attacks and faults. Another line of direction we look at is prevention of attack and privacy leakage. So there are two key streams we look particularly on. This one is, can we make a system secure by design? And can we incorporate privacy by design? When we look at securing the system by design, one of the key particular stream which we look in our lab is reducing the attack surface by deploying MUD, which is IETF 8520 standard. Its MUD is manufacturer user description files, and we did quite a lot of work and have a number of publications in the stream where we looked at MUD ecosystem For example, rule enforcement, IP table versus eBPF program, MUD extensions, MUD user interface for accountability and transparency, and other things. For example, how do you do device or user authentication, authorization, access controls, and encryption. When we look at privacy, again, we look at different techniques. For example, differential privacy, distributed learning, federated learning, anonymization schemes and authorizations, and finally, accountability and transparency. So now today I'm going to talk about thread. So just before my presentation, Eric gave you an idea of a Matter protocol. Matter is application layer interoperability protocol. Whereas, so if you look at this graph on the top, Matter will sit somewhere here, but we still will be building the whole network underneath, which will be networking stack. So many of our IoT devices these days in our house are having, for example, ZigBee protocols or wireless HART or something, which all these protocols are built on top of IEEE 802.15.4 physical layer. And now the question comes here is, how do we include these 802.15.4 physical layer into this Matter ecosystem? So now the first question is, Matter, you just heard Matter is IPv6 based protocol. And because we are bringing interoperability, Matter could run on Wi-Fi, ZigBee, or any other protocol. But how do we make sure now, how do we plug our ZigBee based network in this whole ecosystem so that it is a part of this Matter ecosystem? So that's where the new protocol, which is called Thread, has been introduced in July 2014. Thread Group was launched before Matter, and with the aim that it provides best method for connecting and controlling your IoT devices in homes and buildings. Thread is IPv6 based mesh networking protocol, and it's developed by the same consortium which is developing Matter at the moment. So it is a CSA Alliance and industry-led technology companies. Right now, there are 250 industries is backing up this Thread consortium and Matter consortium. To highlight that Matter and Thread are still not standards. They are still community-driven initiative and bringing this whole ecosystem together, which is run by the industries. So going forward, in market, there are already a number of commercial devices from different companies, for example, Nest or Google. These are the number of devices which are in our labs, which are Thread compliant. The basic characteristics of the Thread network when it is being built or being designed, that the network should be simple to install or start or to do operations. It should be secure, so there should be inbuilt authorization encryption at network and application layer. There will be small, and it should be applied to both small and large home networks for the large commercial networks, and also should allow bi-directional service discovery and connectivity, should provide a larger range as compared to our existing ZigBee or other networks. And one of the main other interesting point here to note is that Thread should address the single point of failure concern. So it should be designed, the mesh protocol should be designed in such a way that if a node, for example, a leader fails or a router fails, the other node in the network take responsibility of that leader and still makes the network connected fully. It should also need to comply with the low power and cost effectiveness. So now, because we have a commercial devices which has a thread network, Google also released OpenThread, which is an open source implementation of a thread specification, which allowed like researchers like us or startup companies or other ecosystem to develop thread based products and deploy those in a different scenarios. So if you look at in this figure, it provides what services or functionality OpenThread at the moment supports that is being part of the thread specification. So OpenThread implements all thread networking layers, IPv6, 6LoWPAN, IEEE 802.15.4 with max security, mass link establishment, mesh routing, device rules, such as border router support. So now let's come back to again 802.15.4 standard. It seems like it's my favorite one. Now, as I said, we already have all these 802 based, 15.4 based wireless technologies. They are already part of our ecosystem. They are not going to go away, and we have to retrofit them into the new ecosystem. And because part of this thread is built on 802.15.4, the physical layer look like this. The whole thread stack is built on this physical and MAC layer. The physical layer features include standard features, which we are all aware of, like modulation, demodulation, switching between transmitter and receiver, fragmentation, scrambling, interleaving, and error corrections and codings. One of the key structure, which we call frame control field in 802.15.4 physical layer, is a 2-byte packet size, and which looks like this. It has a number of fields. And why I'm showing you this, because this is one of the most important bit we find when we are talking about the vulnerability in 802.15.4. So I'll come back to this in a second. So when at a physical layer, when packet arrives at a device which is built on 802.15.4 physical layer, the device driver do one of these sequences. Either tell the device that you go in an ideal mode. For example, many say sleep modes, or in an energy saving mode, or you go to a sequence, receive sequence, or in a transmit sequence, or continuous CCA sequence, OTR sequence means transmit and receive sequence. So now I'm not going to go through all of these sequences, but I will follow you through one of the sequence, which is called receive sequence. So let me walk you through on this sequence. So when a packet arrives at a device, the frame control field as a part of the first, it's kind of a header in the packet, is received. The driver at a physical layer checks the length of the frame. If it's valid, it verifies the frame type and version. When the destination address, for example, personal area network ID and addresses matches, it checks whether these addresses are for this particular node. When the entire frame is received, the driver also verifies that CRC and checks in for that packet. and finally it timestamp that packet after the final bit of that packet is arrived. So if all these checks are passed, the driver passes these received frame to the MAC layer. And that's how from physical layer to the MAC layer, the packet is being transferred. Now, the issue is specifically now, if we look at the acknowledgements in this system, the MAC layer decides the acknowledgement sequence, what will happen if I receive this packet. So in this diagram, I'm showing how these acknowledgements are handled in thread. So if in a thread, a parent device and a child device communicating with each other, there could be a direct automatic acknowledgement sequence could be figured out. For example, parent can send a data frame to child, and child send acknowledgement frame that I have received this packet correctly. However, there's another way of setting these acknowledgements frames where instead of directly sending a packet, a child can request a data frame from the parent. And if a parent has the data requested for that frame, it sends the if a parent does not have any data for that request, it sends a acknowledgement frame with the frame pending bit is equal to 0. It says that I don't have a packet which you are requesting. Again, in the future, if a child again requests a frame, and if the parent has a data for that frame, it sends the acknowledgement, yes, I do have a packet, by setting the frame pending bit to 1, and so on, the communication keep going on. So this parent and child relationship and this acknowledgement exchange in 802.15.4 physical layer is different in both ZigBee or thread network. So if you look in a thread mode, if the driver matches the source address with the entry in the array in the pending list, it sets it 0. So it's another check they do. So if I'm receiving a packet, say child, I know what is the address of a child in my list, and I already authorize this child, then only I'm sending a frame pending is equal to 1, otherwise not. So what do you think what is happening here? What is the problem? You could see if a child, an adversary node, which is not part of the ecosystem, say the child here, we start sending a request to the parent for a data, you can see parent is still sending the acknowledgements. And if it's a battery powered device, say parent is a battery powered device, it keeps sending this acknowledgement every time and draining the power of the device, which is a useless traffic. So this, we thought this is a very simple process. It should be figured that out, this device, even though the value is frame pending bit is sent as a 0 in thread mode, but it's still a problem. And that's what we were able to exploit in our experiment. So before I go into a little bit more detail on that one, I will a little bit talk about the thread network architecture. So in thread network, we could have a number of roles in the networks. So we could have AND devices, which are minimal thread devices with the least requirement on device power and resources, and normally configured at device only. We could have a thread leader. We have a thread router, which is shown as orange color. And we could have a border router. So the role of the border router is where we are running like a matter, basically, because border router connects your thread or your ZigBee network to the rest of the network, which is IPv6 based network. And you can see here. And as previously I said, because of the mesh networking topology, the whole game of the network, thread network, is to make that there is no single point of failure in the network. So now one of the question is, 802.15.4 is a very small frame, supports a very small data rates. How do we incorporate IPv6 on this? This kind of a physical layer. So 6LoWPAN provides a compression mechanism that reduces IPv6 header size sent over air and reduces transmission overhead. There's a 2 RFCs. You can go and read a little bit more detail if you're interested in knowing how that whole compression mechanism work, so that we can take IPv6 packet frame, the longer IPv6 packets and compress it in a 2 bytes long header. So RFC 4944 and 6282. And that's what thread does. The thread stack uses 6LoWPAN to figure out the compressed header for a thread network. So now let's come back to the thread network vulnerability, because like thread, like Zigbee, Wireless Heart, or other 802.15.4 based, all the protocol have all those vulnerability which they had at a physical layer. So thread also have that vulnerability at physical level. So it doesn't matter what you run at interpret at the application layer or network layer, how strong your security protocols are, whether you are using authorization, authentications, or interoperability protocol like Matter, as long as we are not resolving the issues at physical layer, our networks are still vulnerable. So to do some of these tests in our labs, we have SDK boards from Nordic Semiconductor and Silicon Laboratory. We use these 2 type of boards to build our own thread network. We use open thread libraries to install and create the whole thread network. So in our first IoT thread network setup that look like this, we had 4 Nordic boards, and one of the Nordic board's smallest footprint chip we connected with Raspberry Pi to make it as a border router. And then you can, in the bottom, you can see in the orange, we have an open sniffer from Savio. We used it to scan the network and inject packets in the network to create a replay attack. And another Nordic board we used as a sniffer to observe the network, what is happening in the network. So when we create a IoT thread network, the new device, when we connect in a network, has to go through a new device commissioning process. So for example, here the blue dot shows, say, this is a new device you would like to connect to an already existing network. It exchange the DTLS sessions with an external commissioner. So there are different ways to commission. You can use a CLI based tool, or you can use an application. So in our system, we use a mobile apps, which was provided by Open Thread community to commission a device. Every device for this commissioning needed a extended unique identifier. So that's where you can see the barcode which we created. We took the identifier of the devices, and then we created a barcode for the devices. So now in the next app, I'll show, this is a mobile app. which also we downloaded from, which is also supported by Open Thread community, which allows you to security. And then you scan the QR code of the new device. When this shows, you run the joiner command on the device and wait for the join process to complete and device is added. So this is one way of connecting a new device into the network, but there are other methods like through a CLI command, you can do that as well. So this is our new test bed, which looks like this. So now in a new test bed, we have both silicon boards and Nordic boards joined together as a thread network. So first of the device here is configured as a full thread devices, and also which device act as a leader and router. The other 5 devices are minimal thread devices and act as a end devices. So the board where you can see all the devices are attached is is a magnetic frame where makes our life quite easy to arrange our network topology. So one of the thing is Silicon Board community has provided a very good tools and SDK to do the experiment and research on open thread and all kind of research in that direction. So they have a tool called Thread Topology Monitor System, which allows you to even observe your network topology at a given time. So to run thread topology monitor, you also need a Nordic board. So we were running one of the Nordic, this thread topology monitor on one of the Nordic boards. So this Nordic board keeps sending MLE messages to the rest of all the devices in the network. It's like a discovery messages, and keep pinging all these devices and getting the response from them. And in a real time, you can see how my topology look like. So to create an attack, because we needed something kind of a sniffer to see what is happening in the network, we used Open Sniffer from CVO. This sniffer can scan all the wireless channels in that particular area. So for thread network, we operating radio channel, you can see we selected all the 4 bands like 780 band, 868, 915, and 2400, and and after a few seconds, this device was able to tell us which channel my thread network is sending packets on. So we figured out that most of the time my thread network is sending a packet on safe channel number 15. Now with the Open Sniffer, we were able to capture one of these packets and then reconfigure and resend that packet in the network from a third devices, which was not part of the network at all. And we could see this is the same attack, that the device where we are sending a packet, which was part of the network, keep replying to these newly message as an acknowledgement message. So here we can see like packet number 11 is sent, is being acknowledged, which was a replay packet from a non-authorized IoT device. So it confirmed that yes, acknowledgements are still going on. So what we did, we configured some of these Nordic board with the batteries, and we tried to run this attack for like 2 hours with the Python scripts, and we could see that battery drainage happens quite quickly. That because we were not very efficiently doing the power measurement, so I am not very confident that I can present that as a result today, but I can confirm that that has happened. Right now, most of our boards are already plugged on power, so we cannot experimentally show that drainage happens on a powered boards. So that was a replay attack. So we thought maybe let's do another experiment on this network. Here we took a normal packet. So you can see a packet of 32 bytes here, a random packet. We using a Python script library, a Python script which provided by OpenCV library, we were able to replicate and run that, resending that packet again in the network for a little bit longer time, and with the spacing of 1 millisecond. And what we saw after that, if we could confirm that using even a spectrum analyzer, that these packets were going in a channel, for example, number 15, and the interspacing between these different packets is 1 milliseconds in between. And what we could see after a few milliseconds, instead of having the full networking stack, as you see the whole thread network, all of the nodes which were MTD nodes were disappeared. They were not responding to the network. And this happened within a few, like in a 1 or 2 seconds. So it didn't took longer time to do this attack. So it was not even a replay attack. It was just identifying which channel your thread network is currently working on and just bombarding the network with that a traffic on that channel. So now this led us to a little bit investigate a little bit more, which we are currently doing. So we are still investigating, is it a CSMA CA kind of error problem, or is it a network jamming problem? Because if we look from acknowledgement point of view, generally it takes around 169 microseconds from a point when a packet arrives at node and that node sends an acknowledgement. But here in this experiment, we were sending packets after every 1 millisecond. So we assume there was sufficient time for a node to reply to the acknowledgements, but these packets are still dropped because they are not valid packets. So this graph just shows that after few seconds, when we are doing just a sniffing of the network, we could only see the packets which were we were playing in the network, but nothing from our thread network, because thread networks totally stopped working and not doing anything in the network. So these were like are quite primarily result, and it's like, I would say, initial. We are still investigating a little bit more on this direction, but I hope you learned a little bit from this presentation and find it useful. As I said, there are a couple of directions we are investigating on this one. If you would like to follow our work, our development GitHub is thread edge testbed, and our previous version demo, which is recorded videos showing step-by-step of this whole attack, will be found on our github.systronlab/battery thread battery attack, which was recorded by one of my students. And we also presented this in a CompsNet, this demo, earlier this year. Thank you so much for listening. Any question I'm happy to take now. I would like to say thank you to my safety net project team, my colleagues, Anthony Moles and Peter Gillingham, and my previous students who did quite a lot of work in this direction, and all my funders for sponsoring this research. Thank you so much.
So thank you. I have one question from the net. So Peter Steinhäuser is now online, but he has problems to come in. He wanted to look to the calls online. I may read it out on the question from Michael Richardson. Thread 802.15.4 networks are usually encrypted as layer 2. Did your Open Sniffer need to know that layer 2 encryption key?
So that's very good question. So no, at the moment, Open Sniffer was just doing at a physical layer framing. So it was not looking at layer 2, and it does not need to know the layer 2 encryption. Anyone has any other questions?
All right. So there's no further question on the net as I see it. No question here in the room. Thanks for your presentation. You're still around, so you're first RIPE in person here. So grab a coffee with her. Okay, so I'll probably directly hand over to Jed for the last presentation on the schedule today.
Is this working? All right. So as a non-native English speaker, I always feel nervous when I have to present at 12 because I'm not sure what kind of greeting I should use. Should I say good morning, good afternoon, etc.? So being the sensible engineer that I am in 2024, I did what everybody might do in this situation, and I asked ChatGPT which greeting I should use. According to ChatGPT, we have to be neutral, and I can say, good day, everyone. My name is Yadav Cham. I work as a Senior Public Policy Technical Advisor at the RIPE NCC. And today I'm going to present an update on the IoT situation, or as the French might say, an état des lieux. Now, unlike the two previous presenters, I walk a lot, and I was told that that can be distracting, so I apologize in advance if me moving a lot distracts you. All right, so the agenda for today, I'm going to be talking about three almost unrelated stuff. So the first section would cover IoT trends. So these are things that I've noticed in the last couple of years, trends related to connectivity, trends related to the IoT data itself, and we'll touch base on a little bit on IoT security here. The second section, we will be covering the IoT regulations in 2024. So we will see that the policymakers and the regulators have been quite busy lately, and there are quite a few pieces of legislations that would be touching the IoT ecosystem in one way or another. And then finally, I would like to solicit the opinion of the working group members about possible opportunities for learning and development. So let's start. This section will be quick, a little bit of IoT trends. We will start with the IoT connectivity stuff, right? So for a while, we had the sense that not much had been happening in the IoT connectivity scene. Typically, when we talk about cellular IoT specifically, there are different types of categories there. So we might be talking about massive IoT, where we need lots and lots of devices, usually that require not a lot of data rates. So typically we had connectivity options like narrowband IoT or LTE-M, which were both considered 4G and 5G technologies, and that served the purpose. But as we started moving into other category of IoT devices, so we talk about critical IoT, we talk about industrial IoT, or we talk about broadband IoT, then these devices required not necessarily a high density capacity, but more throughput. And typically, we could have served that using one of two things, either the LTE category 1 through 4, or if we had 5G deployments, we had to go through legacy next releases. So I'm going to put this a little bit to the side and go through the points that I've mentioned here. So one of the things that we've been seeing more and more happening in the last couple of years is the introduction of satellite connectivity within the IoT ecosystem, whether it is for local backhauling or to ensure global IoT services. So now we see more and more providers, we see more and more advancements talking about hybrid terrestrial networks and non-terrestrial networks. We also see a trend going through the pushing IoT deployments within private cellular networks. So that usually happens for specialized IoT deployments, let's say certain agricultural firms, in very rural areas, or let's say we have a industrial plant that requires very low latency, very high data throughputs. So we see more and more private cellular opportunities there. And typically, either of these two options, the use of global satellite connectivity or the private cellular networks, it had been empowered by the increased adoption by IoT device manufacturers of technologies such as eSIM or iSIM or their appropriate provisioning solutions. So we're talking about the EUI-ICC or the integrated EUI-ICC. And now I would like to circle back to the 5G advances. And during the last 2 years, mainly, the 3GPP had release 17 and release 18 being finalized. I believe release 17 had their code freeze in Q2 2022, and release 18 had their code freeze now in 2024. So what they brought to the table is a new category of connectivity within 5G, and that is the RedCap. RedCap stands for reduced capacity. So while before the type of connectivity for IoT that I mentioned earlier, where we required potentially higher throughput, either we had the option to do it through LTE Cat 1 till 4, or we had to go for a full-fledged 5G new radio infrastructure. And that meant that the device complexity, the device cost was very high in 5G. With the introduction of the release 17 and release 18 RedCap, now we can have IoT devices with a complexity reduction of somewhere between 50 to 65%. So, and typically by all estimates, that would be around 60% of the IoT devices by the end of 2028. So with this whole movement, we see more and more optimization of the 5G options for IoT connectivity, coupled with non-terrestrial options in order to deploy, globally available IoT solutions. So this is what I saw in the last couple of years when it comes to IoT connectivity. Now, there are some trends when it comes to the IoT data side of things. And it wouldn't be a technical conference in 2024 if we don't, mention the magic 2 letters, AI. So we see a lot of AI or LLM being used to treat the data, to filter the data, to do an analysis of the data. So in all major conferences, a big part of the work that has to do with IoT data is trying today to explore how AI can fit in this space. More specifically, given that we have more throughput power, so we have IoT devices being able to generate a lot of data, instead of pushing all of this data to the cloud, the topic of edge computing is becoming, or treating fog computing, or more specifically in the IoT case, what we refer to as edge IoT, where we treat the data closer to the device. This had been, if you want, expedited by the introduction of AI. So now we hear about video cameras with embedded AI inside them, where they can treat the frames, relay the needed information or not, etc. So I expect to see more and more advancements in that space. And that also leads to the last topic that I've mentioned here, which is digital twinning. Through the conferences that I've been following, through the works that I've been seeing, and some of the initiatives and the reports that I've read, it seems that digital twinning is an excellent use cases for the use of the use of IoT. A McKinsey report expected that digital twinning would be increasing 60% every year between now and 2028, with a potential market of $75 billion. So a lot of IoT data handlers are investing more into the whole digital twinning space. We see it quite active in the military space, in the automotive space, and the industrial space. We see more and more governments and moving in that space. I live in Dubai. The UAE government over there, they went into a full-scale digital twin of the whole city in order to test things, model things, and so on. Now, before moving to the second section, I just want to add a couple of notes related to the use of AI in the IoT ecosystem, and that's from a cybersecurity perspective. So there are three things that we consider when we say we're using AI and security. So AI can help the network operators or the service providers to try to mitigate cybersecurity threats. We all know that the botnets are being smarter, not all devices being used at the same time. The pattern of the attacks are changing. So arguably AI can help us understand and mitigate and react faster to these attacks. So that's the first component when it comes to AI and security. But AI can also be used by the adversaries and the malicious entities in order to mount smarter attacks. So that's the other side of the coin. And third note that should be considered going in the future, when we're saying that we have stuff like edge AI and we have AI computing all of these data, the AI itself can be compromised, either the model or the data that feeds inside the AI. And the motto, garbage in, garbage out. So with this, I would like to move to the second section, which is IoT regulations in 2024. In a nutshell, I try to put things in perspective, and these are more or less the pieces of legislations that I believe we should be interested in and looking at during 2024. I try to limit myself to the EU, the US, and the UK. There are a lot of other pieces of legislations in other places of the world. For example, Singapore is introducing a cybersecurity labeling scheme for IoT devices. There are some stuff happening in the Middle East between the UAE and Saudi Arabia. But what I'm going to talk about here briefly is some of these, and these mainly are EU predominantly, a little bit of UK, and a little bit of the US. Now, keep in mind that these are things that are relevant in 2024. I mean, either they've been voted on in 2024 or recently voted on and will take effect in 2024. There are some other pieces of legislations that still apply to the IoT world, like, for example, the EU Cybersecurity Act, or that was, I think, in 2019, or, for example, the US Cybersecurity Improvement Act that was, enacted in 2020. They are still in effect, but I'll not be talking about these. So I decided to choose three of these in order to talk a little bit more about them. I will not be going into the details of them. If you'd like, we can talk more during the breaks. I also have RIPE NCC colleagues like Desiree or Roman that follow these legislations very closely. The first one is NIST Directive 2. Last week, there was the ENISA Telecom and Digital Infrastructure Cybersecurity Forum in Helsinki. And I can tell you that the NIST 2 was said more than 100 times. So it's the big thing, right? You might be familiar with the NIST directive that was issued back in the days. Well, NIST Directive 2 is here to broaden the scope of the entities and the sectors that falls under the NIST directive. All right, so it introduces the necessary structure and procedures for cyber crisis management. So it defines what are the thresholds of the security incidents that happen. So at what point should these entities start reporting? and to whom they report, right? And this applies to either essential entities or important entities. Now, how they define these, it can either be through a sector, like let's say utility companies would fall under essential entities, digital service providers might fall under important entities, or they also have a certain classification based on the size and the revenue of the companies. So for example, for what they consider as essential entities in terms of size, could be 250 employees and up, and revenues of around 50 million euros or so. But the interesting part here is that NIS2 is not a law per se, it's a directive. And the member states of the EU, they have up until 17th of October 2024 to create national legislations that would cater for the NIS2. And each member state has the possibility to decide on their own as well what to include as an essential entity or what to include as an important entity. So digital service providers, or what they might refer to as critical infrastructure. So let's say you're running an IoT solution for smart metering or for plant automation or for utility management, whatever the case is, they might fall under the critical infrastructure, and you'll have to be follow the specific regulations. Now, it also introduced some very very strict frameworks for reporting and compliance. So that's NIS2. The second one that I wanted to report on is EU Cyber Resilience Act. And a lot of people think that this is the biggest move in EU regulations since the GDPR. It is coupled with the EU Cybersecurity Act, but while the Cybersecurity Act introduces more voluntary programs or frameworks, the Cyber Resilience Act, it proposes legal obligations to ensure high level of cybersecurity across the whole EU. And the scope touches everything that has a digital element, whether it's hardware-based, software-based, or plainly defined as an IoT device, wearable, either it's directly connected or not to the internet. And the regulations, it follows the whole life cycle from the design phase all the way to hitting the market, all the way to maintaining it, making security patches available, but also disposing it and, end of service and end of support. Non-compliance will be penalized, and they are introducing, I think, a fine of around 10 million euros or 2% of a company's worldwide revenue if they fail to comply with this. Now, who are affected by the Cyber Resilience Act? It's the manufacturers, the distributors, the importers, and the retailers of such digital products. So in a nutshell, they are trying to cover the whole supply chain for the IoT devices. And this most likely is focused on the consumer side of things. Now, when it comes to timeframes, the European Parliament approved it in March 2024. So we should start seeing more and more uptake for this really, really soon. Now, the third piece of legislation is the UK Product Security and Telecommunication Infrastructure Act. I had to abbreviate it to fit it here. So basically, it covers three categories of devices: either internet connectable products, network connectable products, or computer input products. And what they cover here are what is labeled as a UK consumer product. So per se, the products that are used for business to business things do not fall under this legislation unless the same product can be used by consumers. Also, they enforce some sorts of management of the whole life cycle of these consumer devices, and failure to comply will come with hefty penalties, either product recalls, fines up to £10 million, or 4% of the worldwide revenues. And who does it apply to? Manufacturers, importers, and distributors. What is the time frame for that? It took effect as of 29th of April 2024. So some of the things that they would like to see here is that they don't want to have devices with default passwords on the market. They want consumers, when they buy the devices, to be able to have access to information as on how long the product will be supported. So it should be clear from the point of sale. So this device will be supported at least for the next 5 years. And it also requires from the manufacturers and distributors to have disclosures of vulnerabilities or security incidents, or for example, if there are patches or not, if these patches will be automatic or not, etc. So I also believe there are 3 other pieces of legislations that we should keep an eye on. The first one is the EU Cybersecurity Certification Scheme. So you might be aware that within the EU space, there's a program that tries to certify different things, right? So cybersecurity labeling scheme. There was a vote that was supposed to take place in April 2024, but it was shelved a little bit till May 2024. And it relates to the cybersecurity of cloud services. Now, while this might not affect directly the IoT product themselves, but as we realize today, a lot of the backends, the command servers, the servers that ingest the data or manages the devices of the IoT devices themselves, they live in the cloud itself. So arguably, this will have an effect on the cloud providers that host the IoT backends and the brains of the IoT solutions. The second thing is the US Cyber Trust Mark. So the FCC actually voted on this in March 2024. It will come in effect a little bit later on in this year. So what they define is a voluntary cybersecurity labeling program for wireless consumer Internet of Things products. So just like, back in the days when we used to go to our favorite electronics shop and get a router and says, this is Wi-Fi Alliance or certified or whatever the case is, they will have a new label there, which is called the US Cyber Trust Mark. They are proposing also to include a QR code where the consumer can scan it and will get easily understandable information about the status of the test conducted on these devices, whether there are vulnerabilities or not, how long it will be supported, whether they should be doing regular updates themselves or the security updates will be pushed automatically to the devices, etc., etc. So again, that's a voluntary cybersecurity label, but the idea is that hopefully this incentivizes the manufacturers to all move towards this labeling program and hence improve the status of security for everyone in the market. They count on public and private collaborations. There will be certified labs where they test the different devices. And finally, you might be aware of the Radio Equipment Directive in the EU. There is not an amendment, but there's something called Red Article 3.3 that talks about cyber security of digitally connected components that have a radio equipment inside that. It was supposed to be enforced in 2024, but that was postponed till August 2025 because the scope upon which, like the number of products, the categories of products that it covers, it's quite large. So basically anything with a radio equipment, which nowadays can be everything, has to follow under Red Article 3.3. And specifically, there are 3 parts. Article 3.3D that talks about improving the network protection, so about the radio interface itself, making sure it's compliant, it doesn't cause disruptions, etc. Article 3.3E talks about strengthening the personal data and privacy protection, so it talks more about the devices themselves. And there's Article 3.3F that covers the devices that are used more specifically to handle transactional data, like financial transactional data. And here they try to reduce the risk of fraud, so stuff like authentication, proper authentication, and these kind of things. So this concludes the IoT regulation landscape for 2024. And that brings me to the last section for today, and that's IoT capacity building. And a small trip down memory lane. This topic was first brought up back in RIPE 84 at Berlin. So I took the stage and I asked the room whether you think that the RIPE NCC should develop some learning and development material, whether it is training courses or webinars or one-off workshops related to IoT topics. I can say that I received mixed feedbacks back then, so to put it in a politically correct context. So some people were in favor of this, some people were not in favor of this, some people did not speak directly in the room, but later on reached out to me on a private basis. There was a little bit of discussion on the mailing list following this. Some people proposed that the RIPE NCC join forces with other organizations that talk about IoT security, etc., etc. But nothing really materialized out of this discussion. But between then and now, there are two surveys that were conducted by the RIPE NCC. One of them was the 2023 member survey. Hopefully everybody in the room had access to the survey and included their answers. And in both of these surveys, there was a question related to training activities. So what kind of training topics, what kind of training engagements would bring value to you? So in the first survey, the first one here on the slide, where we received 3,518 answers, 22% of them did report that they would like to see something in IoT because it is important for their jobs, for their operations, or for other reasons. And within a smaller survey that was conducted by the Learning and Development Department at the RIPE NCC in Q4 2022, out of 250 responses, 28% of them said that they see value in this. So based on this, maybe, if I can get it, second time is the, sorry. These pesky animations, I don't know what's happening. Second time is the charm, maybe. So I would like to solicit input from the working group, either right now, later on the mailing list. Do you think there is a need for the RIPE NCC, specifically the Learning and Development Department, to tackle topics related to IoT? We know, for example, that in 2021, this working group published a BCOP document related to architectural security design considerations for IoT, for home IoT devices. But maybe it could be a webinar related around that. Maybe it could be an awareness activity engagement related to that. I know that in 2023, there was a request on the mailing list about a possible BCOP document on thread and matter, but this is not finalized yet. So I'll leave it here and solicit any questions, feedbacks, complaints, ideas. We're open.
Good day from my side as well. I hope you can hear me.
That's okay.
Good.
It's Peter Steinhauser there. Sorry.
All right. I think we should start with the questions from the audience first, right?
Yes.
Neil O'Reilly, right Vice Chair. And for me, good morning. I haven't had lunch yet, so it must still be morning. But one small point of information, since the participation in the working group isn't restricted to RIPE NCC members, not everybody in the room would necessarily have access to the RIPE NCC member survey. And there may well be interest in the kind of learning and development initiatives that you're talking about among the broader RIPE community. You might consider whether it could be made more available, more widely available.
You mean the surveys or the offerings that we do?
The offerings.
Yes, we did consider this. And for example, the webinars that we give at the RIPE NCC are now not only for our members, but also for others.
We don't need to take up lots of meeting time.
Yeah.
Yes,
This is something that we're actively considering and we're trying to see how we can manage our resources to do. Good point.
Okay. We also have a question in the Q&A section from Martin Botterman from IGF. He was asking regarding trends, what is happening to minimize the carbon footprint of IoT devices and services? Is this already generally considered in the design process today? Both energy use, material use, and longevity, recycling, reusability of devices.
Good question. I can provide a partial answer to this. So for example, one of the incentives to introduce the red cap connectivity options for within the release 17 and 18 is that it allows to have the same peak rates, but at a lower energy consumption ratio. So maybe in that regards, this is more geared towards sustainability. Unfortunately, I don't have much, how can I say, insights on how to reduce the net footprint, like the carbon footprint within the IoT connectivity space itself.
Thank you very much.
Pleasure.
So I don't see any further question in the room. So Chad, thank you again for linking it back to the NCC work. So coming to the last agenda point, want to be quick. So we are about to ask for a new co-chair here in the session. And so we have David Schweitzer, Peter Steinhäuser, you just see him, and we have Andre. And I want to just give the opportunity also to David. He is here in the room to have just a small greeting. And if you could manage to give Andre then also the microphone after David to just also make him visible. And then we want to close the round. There's a question on the...
Yeah, Peter, Jim Reed's one of the founding co-chairs of this working group some years ago. I've had some private conversations with yourself and with your co-chair, Peter. I'm very concerned about this development because, first of all, we decide things by consensus, and the use of a meet-echo poll seems to be a violation of the way in which we do co-chair selection in this working group. And I also don't like the idea of using votes. This is discriminatory because you discriminate against people who will not use meet-echo or are able to use meet-echo. If we were using the mailing list to make consensus decisions, it's open to everybody. And I'm strongly against what's been done here. I'm very, very surprised this has been allowed to happen.
Okay, thanks for that input. So I have another input and then I may answer to
Martin Winter, speaking as a co-chair from the Open Source Working Group. I strongly object to the mailing list version, and if you don't know why, then attend the Open Source Working Group tomorrow afternoon, what happened in our case the last time.
Okay, thank you. There was not much activity. So as I joined the group, then it was very hard to get the election done on the selection done on the group. So this one we tried to just use the participation here in the room. I saw other selections where then the cheering in the room itself made the vote. So maybe that is not not the end of the evolution of finding a good way forward who is balancing all of the things.
We have an election procedure, appointment procedure that's documented, and that says we decide things by consensus. So I don't understand why we have deviated for that. Whether we decide things using a mail list or not is neither here nor there. But the fact is we make decisions by consensus. This smells of making decisions by votes, and I think that's very wrong because it limits the participation. If we decide things using the mail list in particular, it's open to everybody. By doing this with a vote with Meet Echo, you're limited it to either the people that are in the room or the people that can open up a Meet Echo client. There are people other than that who may want to have a vote or have some kind of say in what's being done, and that's being denied to them because of the fact of the way you've chosen to do this. And I don't remember anything being announced on this mailing list to say that's how we're going to do things or having any kind of discussion about changing the selection mechanism. I think something's gone very badly wrong here.
Okay, thanks. Noted. So I published it in the mailing list quite beforehand. As I said, on the 7th of April, the candidates had a chance to also put their input into the mailing list, and there was some echo from the mailing list. And so there was now the choice to get it done, Meet Echo. So that is the way we are collecting it now. So I'm happy to take it forward. So we have tomorrow also a session with Miriam directly on the various things. We meet as the working group chairs and see the different ways we did it and the experience, and to develop it further. Okay, maybe just still give David a quick chance to say hello.
Hi everyone, my name is David Schweitzer. I'm currently working for the Network Device Education Foundation, and I am a person who is really interested in IoT devices. I really like to play around with hardware, and I try also to meddle around with the firmware of all the devices I own. It's a really kind of a personal interest I have in all things considered when it comes to the device security and the data protection and, for example, the user privacy for the end users of those devices. If you have any questions for me, you can either meet me in the hallway later or maybe if we have the time, we are slightly over time, you can ask them now.
Okay, thank you. And hope, Andre, you're online. We don't hear anything from you.
I'm following RIPE meeting from the very beginning. And I'm a director of IoT Association in Russia. And basically, this is NGO, and we have a members who is doing different things in IoT field. It's like everything from the devices to the applications, security, API integration, and all that stuff. I actually wrote my little bio in the email, and just echo of this meeting and the previous very interesting and very compressed report. I should add that what I think about the working group is that there should be some balance between the what we call the human IoT, the IoT for the people, and the industrial IoT, which is about 50% money-wise worldwide. So 50% generated by people, 50% by the industrial. And I think that in the group, there must be some practical focus on some of the industrial cases, including security, including the digital twins integration. As it was already said, the ESG part of it, because IoT plays a significant role in the ESG. They also some very, very interesting development in the V2X family of the protocol for the transportation and self-driving cars. There is a whole world of labeling, addressing, resolution for the IoT devices and data sets. It's a whole world which also can be covered in the working group. So it's a lot of things actually to do. And if you take the industrial part of it, it's all verticals like agriculture, which I personally really like and I enjoy it. Having a lot of experience in agriculture and IoT. There's transportation, logistics, there are low orbit satellites. So that's a whole world of the IoT which can be discovered in the working group in the form of like little pitches about the case, particular case, problems, addressed problems, the resolutions, the experience and things like that, just to make it more fun. Because if there is no fun, I mean, what's the reason of it? That's my position actually for the group. Thank you.
Okay, thank you, Andre. So I think the vote is now coming down to close. So that is to collect just the opinion from the group. So I want to thank you for all the participants and also to say you're not need to be a chair to contribute to the group. No? Especially the chair has some facility tasks, but the main drive-through comes from you participants. And so there is no, please don't hesitate if you have any points. And as we have now 3 candidates, maybe 2 will not get co-chair, but that should not hesitate block you from doing any work within the group and then get things forward. That's one.
Neil O'Reilly, right, Vice Chair. There's one small detail that I've missed, perhaps because I wasn't paying attention and everybody else in the room knows the answer, but just for clarification, how many vacancies are there?
So there's one co-chair, so the end of Peter Steinhäuser's role, and we're looking for a new one.
Okay. So it was 3 candidates for 1 place.
Yeah, so that is the candidate. So we again we announced also the way how we're doing it on the mailing list on the 7th of April, and there was plenty of room of doing a discussion, and it was the one role which we applied.
Thanks for clarifying.
Thank you. So I think we can close the counting. Does anybody have a direct look to the results? So is it now that what I see in a mic echo? So can somebody? Sorry, I'm not that experienced. Okay, so you made. I have a. Is it possible to have it online here? Or good. Okay, so playing with the latest technologies. So we have 8 supports for Peter. We have 3 for Andre and 1 for David. So Peter, you're continuously running the work group together with me. And if you're looking for next slot, so my term is now in the middle of the term, so in 1 year's time, there's another chance to come in. And again, Peter, Andre, please do not hesitate to put your work into the group and share your thoughts. Thank you very much.
Yeah, also from my side, thank you very much for all the attendees. And a quick comment on Jim's remarks. I think we should take it very, very seriously. And I agree absolutely that the discussion about the selection procedure should have been, let's say, better handled on the mailing list. Because I agree with Jim, it's the working group's decision how to do this process. So we really have to take this very, very seriously. And Jim, my apologies for not doing things the right way. Okay, thanks everybody.
Okay, thanks. So closing the Jim, sorry.
Just another remark on this. Peter, there's no need to apologise. You know, what's happened has happened. I think we have to make sure that something like this doesn't happen again. My personal view is that if the working group wants to change in the way in which it wants to appoint its co-chairs, it's perfectly free to do that. We just need to get consensus for a new appointment mechanism. So I have no strong feelings about how the working group wants to do this thing, because I think it's time for old farts like me to step into the background and leave it to the next generation to take over. But I do think if you're going to make changes to this, the mechanism has to be properly discussed and worked out in advance, rather than just imposed on us in the way it has been this time. I have no strong feelings about how you want to do this in the future, but I think when we've got a procedure, we should be sticking with it until we figure out it needs to be changed. Thank you.
So again, also from my side, thanks for your feedback. So it's definitely that we learn from the feedback and see. So the impression from my side was cheering in the room and you look for the applause may not be the right way of doing it. So involving also the remote participant. So we will have a work group meeting tomorrow, which then looks into the aspect and the ideas from the various groups, and we will definitely evolve on this. Thanks also for your feedback. And if there's any further ideas, please also share with the full group so we can only develop together. Thanks so much. Sorry for running out. Also hope now the queue on the lunch is not that long anymore, so then you can grab your lunch directly. And thanks for your participation.